Yes. Hello, students. Today we are going to study the kinematics one, that is with uniform motion and where the acceleration is zero, and those cases also will take where the acceleration is variable, right? But let me start with a very basic, because kinematics is related to motion. This word itself is very crucial. See, when I say a body is in motion, it is always in relation to something. I can say, yes, a train is moving with respect to platform. But if I am sitting in the train may be in the rest position. So first thing you must all learn, motion and rest, they are relative to each other. When I say a body is moving, I have to define something which I call as in rest. Suppose we are in this room, I can consider you in rest position, or maybe this board in the rest position. But is it truly in the rest position? If somebody is sitting from outside this atmosphere, he may find all of us, we are in motion along with Earth. So when we define a particular problem, very first thing one has to understand that which point or which object I should take in rest position. Once I decide that, then with respect to the position of that object, I can define the motion of any other object, right? We study motion in two branches. One is known as kinematics, which we are dealing today, kinematics, and other we call dynamics. Let's understand first of all the small difference between the two. In kinematics, we talk about the motion and rest, but we never talk about the cause of the motion. If a body is in motion, who makes the body in motion? We are not concerned with that. We define the parameters of the motion, how these are changing with time, this what is our concern. But when we come to dynamics, we do talk about the cause. And what's the cause? Cause may be a force. So let's forget about the cause for a minute and deal with what we call kinematics. As a first part, we'll deal with only one-dimensional motion. 1D motion. In short, I'm writing it like this. What is a 1D motion? A motion in a straight line is one-dimensional motion. Now, to put it into mathematics, so that we can solve the problem associated to it, we have to first of all define our origin. Origin may be somewhere here, or maybe here, or even at any other point of convenience. When I say this is origin, the position of a particle, I'm indicating it as P, is given by a coordinate. I don't need all the three coordinates of the space. If my straight line is, say, along the x-axis, for me it is sufficient to give one coordinate, that is x coordinate. My choice is mine. I can take this as y-axis, I can take this as z-axis. It doesn't matter. But once I decide, yes, this is my x-axis, x is the position of the particle, then I forget about the y and z coordinate. I need not bother about it. Now, position is one important physical quantity related to the motion. When particle is in motion, this x is changing. That means the position is changing. How is it changing? You can always talk about what we call as velocity. There are many types of the velocities. Average velocities, you may say instantaneous velocities. But most of the time we are concerned with the instantaneous velocities. I'm using calculus, assuming that the basic of calculus is known to you, though I'll explain it in simple manner. But we write this as dx by dt. Or sometimes we call this as differentiation of position with respect to time. Now, why we say that this is instantaneous velocity? Let's understand this a bit. During this discussion, I will give you a brief idea about the calculus, how we can use calculus in solving the problem. Especially for the competition type of problems, calculus is very, very important. You will learn calculus in mathematics in detail, but we require a bit of calculus at this stage. To explain this, I am taking a very simple situation where I am showing the position on y-axis and time on the x-axis. Once again, this is my choice. I can take the t here or I can take the position here. Sometimes we say that time is an independent variable and position depends on time. That's why we prefer to put the dependent variable on the y-axis. But when you're dealing with the question from a competition, you have to care for this. Is it really that the dependent variable is on the y-axis? They may give it on the x-axis too. So for competition, we have to be extra alert. All you remember that if there is a variation of the position with time in a straight line manner like this, we call this motion as uniform motion. Uniform motion means where velocity is constant. How can we calculate velocity? For that, I need 2 points anywhere on the straight line. For straight line, I am very, very clear. There is no problem at all. This point corresponds to the time t1 and its corresponding position is x1. And this point corresponds to the time t2 and the position is x2. x2 may be more or less depending upon how the variation is there. And we say, yes, the velocity is x2 minus x1 divided by t2 minus t1. All of you are aware of this particular formula. Okay, very good. I can take the point, this first point may be here, or I can take my second point at this position. I'm going to get the same expression for the velocity or same value for the velocity. But situation is very different if the variation of the position with time is not a straight line. Let's have a more realistic situation where the particle is having its position changing with time, not in a straight line. Maybe like this. Now, if I choose my 2 points in the same manner, depending upon how I am choosing my points, the ratio of x2 minus x1 divided by t2 minus t1 is changing. Obviously, velocity is changing. But can we use really this formula in this situation? We can't use it directly. This formula is applicable for a straight line. Look what Newton suggested. It's a very intelligent idea he took. You can see this is a straight line. No, it's a curved line, obviously. Let me draw one curved line like this. Or make it more curved, huh? Like this. It's a curved line, everybody can see this. Let's take only small portion of it. Are you able to feel the curvature in this line? Very difficult. Even if I reduce it further, it becomes even more difficult for you to recognize the curvature part of it. It's very obvious. See, surface of Earth is spherical, nearly spherical. But have we ever felt it that it is really spherical? Hardly we do it because we are looking only a very small part of it. Newton used this simple idea to use this equation for this type of a curve. He said like this: you take a time t, find out the position for that particular time, increase the time by a very small amount. Very small amount. I'm not showing it that small, but it should be as small as possible. You can write this time as t plus dt. This dt stands for increment time, which is so small that I can take this as almost equals to 0. Not 0 exactly, close to 0. Obviously, there is a change in the position too. I don't expect a very large change in the position x. I say the position change is x plus dx. Now focus only on this part. Forget about this portion. As I told you that this line appears to be straight to you. And of course, this is very close to straight if dt is very close to 0. Then I can use this formula for this. And if I use it, then I get the velocity as x2 is equals to x plus dx minus x1 is position x at time t, divide this by dt plus dt minus t. And if you simplify, you get this as dx by a dt. But then this velocity is not the velocity of the entire motion, because it's not a uniform motion. There's one simple way of handling it. At this particular point, you draw a tangent, a line which is almost touching it. This straight line will have a slope exactly equal to dx by dt. We call this velocity as an instantaneous velocity near the time t. You may say even at time t plus dt, or you may say even in the middle of it. But this is close to time t, so we say this is the instantaneous velocity of the body at time t. If I need velocity at some other time, very nice. Suppose I want to know the velocity at this time. Either I go by whole of this process, or I can do one simple thing as I told you. You draw a tangent again. And from this tangent, you again get the slope dx by dt, and that will be the instantaneous velocity at the new time t. So this is to be kept in mind when I'm using this dx by dt. I'm talking about the instantaneous time. Instantaneous time means at a particular instant, at a particular time. I hope this part is clear to you. Let's come to the next part of it. When I talk about the velocity and is not constant, what is the rate at which it is changing? Yes, for that we have a parameter, we call this as acceleration. And in the same line, I can say this is the rate of change of velocity with time. You can even go beyond and say that, of course, there may be some rate of change of acceleration. We call it as jerk, or you can name it any way. There is no end of it. But up to this stage, I think we are able to handle, especially those motions which are very common in our surrounding. So up to acceleration, we are interested. And if we go beyond that, where the acceleration is variable, we use calculus, details of the calculus to handle it. It means I can even talk about the rate at which the acceleration is changing. That is dA by dt. Or even the parameter which I take, even that may be changing. So this is a sequence, but up to this stage, I think it's sufficient for us to handle. Once you are aware of the parameters of motion, let me quickly revise this. Time is one important parameter. Position, velocity, and acceleration, they are the parameters of the motion. In a motion, maybe x, v, and a, all the three are changing with time t, or maybe some of them is constant and others may be changing. But a study of the variation of these three quantities with time, that is what we include in kinematics. We write equations, we solve equations, we use mathematics, and we try to establish the relation of all the three with time or among themselves also. This is what is kinematics. How we do it? There are again two methods of doing it. Now I'm taking the kinematics. How to handle it? One is a very simple method of using equations. Another is method of using graphs. Both these methods are useful, and we use both of them to find out what is the solution of a particular problem related to the motion. Let's first of all deal with equations. The equations which we have, let's start with acceleration. As I told you, acceleration is nothing but is dv by dt, and I am keeping it in mind that this is the instantaneous acceleration. This is one equation you can use. This is a basic definition of the acceleration. There is another version of it. You take dt on this side, and you can write dv is equals to a dt. And if I go for the integration of this, for which I am using this symbol for integration, putting limits, say from time t1 to t2, and corresponding for time t1 the velocity say is v1, and corresponding to time t2 the velocity is v2, is another equation to handle it. Although these two equations are equivalent equations, but we say that this is the differential form of it and this is the integral form of the same. Similarly, I have another equation, v is equals to dx by dt. Similarly, dx is equals to v dt, and if I go for the integration, right, from time t1 to t2 of my time interval, which is concerned to our problem, x1 and x2, and if I solve this equation, I'm going to get the information for the position. If I solve this equation, I'll get the information for velocity. Again, these two equations are equivalent. This is the differential form and this is the integral form of the same equation. In fact, you can say 4 such equations. These are the general equations, and you can use these equations in any of the problems. Whatever may be the problem related to kinematics, we are using these general equations, which are nothing but they are the definitions of these quantities. But apart from these, we have some, say, cooked equations, you may say. We have used these equations to obtain these equations which are already cooked to some extent, and you can make use of it. I'll come to graphs later on, but let me give that few cooked equations to you. See, when you are dealing with a competition, let me give a brief idea about that. There is a different approach we have for competition. If you are preparing for your CBSE board examination, the approach is slightly different. For competition, first thing which everyone must keep it in mind, that when you read a question, you must recognize that which is a particular topic to which it is belonging to that particular topic. Moreover, which appropriate equation is to be used in that question. It is not that all equations we can use. There are certain restrictions. So you have to pay special attention for these restrictions, which I am telling for the first time to you in kinematics. But if, now when I say if, it's conditional. If acceleration is constant, that means it doesn't depend on time. It's not changing with time. I can use few equations which I'm writing here. V is equals to u plus at. I think no need to give you parameter. V is the final velocity, u is the initial velocity, a is the acceleration, and t is the time interval. Please keep it in mind. I am taking u is the velocity at time t equals to 0. One can take anything else also. I can rewrite this equation in this manner. Look, velocity t2, velocity t1 plus a t2 minus t1. This is the general version of the same. But most of the time we take this t1. Please don't consider that there is a multiplication between the two. It is a functional form which I have written. V at time t2, V at time t1. But when I take time t1 as 0, I can write this as u, and I can write the final velocity as v for simplicity, so no need to write every time the same thing. But then this t2 minus t1 is my t. So please take this in mind that t is not time, t is the time interval. Time interval, I'm taking a motion, I'm not considering it right from the beginning. I'm considering it after some time. That will be my t1, and up to this time t2, the interval is t2 minus t1, which I have to consider. That's all. This is the first equation, very well known to you. You have done it in your earlier classes also. There is another equation. S is equals to ut plus half a t square, a new parameter. S, what is S? Is a displacement. Is a displacement. And what is the displacement? The final position minus initial position. U is the initial velocity, A is the acceleration in the same manner. One can write S as x2 minus x1. Right? So S is not the position again. It is a displacement. U is the initial velocity. Do you know there is similar version of the same equation as S is equals to Vt minus half a t square? For competition people, you have to remember it. See, in a particular question, I am not given the initial velocity, but I know the final velocity. Suppose I throw a ball in upward direction, and I say, okay, what happens when it reaches the top? When it reaches at the top, its final velocity will become 0. I will prefer this equation. I am not concerned what is u. V is 0, this will go, and now my equation becomes simple for me. So these are some of the tricks, you keep it in mind. It is nothing. What I did, I replaced v by this u by v as u is equals to v minus at. You put it here, solve it, you will get this equation. So this equation, when you are very well clear about the initial velocity, this equation when you're sure about the final velocity. So select this same thing. Then I have a third equation. Third equation is v square is equals to u square plus 2as. Now this equation in fact is the energy equation. How can I say this is an energy equation? Later on when we'll come to dynamics, I'll merge these things. But I'm showing it here to you because for competition people, you have to know that what is the easiest way of getting the thing. Why to go for unnecessarily for mathematical details of it? Because two things are very important in competition. One is the accuracy and other is the timing. If you are able to do the question accurately in less time, that's what we require. That must be your goal, right? Look, if I multiply this by half mv square and again half m u square plus half m a s, I'm getting a very interesting equation. Look, half mv square is nothing but is the final kinetic energy. This is the initial kinetic energy. What is ma? Force. For 1D there is no problem. You have a force and displacement in the same direction. You can take this as force into displacement, that is equals to work, right? There is 2 also, which I forget. You remove this 2 from it, this 2as, which we have replaced. And once this 2 will go, this ma is the force and s is the displacement, and that will be equal to work done. So its final kinetic energy equals to initial kinetic energy plus the work done. So this is basically the energy equation. Whenever we need, instead of using this, I sometimes use this equation to handle this problem. There is another equation, which is a very specific equation in the same category. That means when acceleration is constant. Please keep this in your mind very, very carefully. One should not use any one of these equations once you are sure that the acceleration is not constant. Then what is the alternative? Use general equation. General equation you can use even when acceleration is constant, because all these equations we have derived from same general equation set of the equations. Now my fourth equation is a very special equation. Sn is equals to u plus a by 2 2n minus 1. Please understand this. U is the initial velocity. But what is this Sn? Sn is the displacement in nth second. What is this nth second? Let's take an example of the 4th second. It means motion started from here. Particle is moving on a straight line. When it started from here, I counted the time as 0 second, you may say. Now, when I say 4th second, I'm concerned only with the motion once the 3rd second is over. 1 second is over, 2 second is over, 3rd second is over. 1 second, 2 and 3rd. And once the 4th second is over, this one, I'm only concerned with this displacement. I say this is S4. See, S4 stands for the displacement in the 4th second. When 4th second actually starts, when 3rd second is over. From there till the 4th second is over, whatever is the displacement that I represent as S4, and in general, if I talk about the nth second, I write this as Sn. Please look at this equation carefully. This is not dimensionally correct. Look, this is displacement and this is velocity. You must have all the terms in the equation having the same dimension. There's a dimension mismatch here. Further, if you go, this is the number, this is the acceleration, even its dimension is not there. Can I say this equation is wrong? Dimensionally, yes, but numerically it is not wrong. In fact, if you solve this equation, you will find this is u multiplied by 1 second. Velocity multiplied by 1 second is displacement. But since it is multiplied by 1, we are not writing it here. And same is the case here, it is multiplied by 1 square. 1 second square. That means time square multiplied by acceleration is again displacement. So equation is numerically correct. You can use this equation, but you have to be careful. Are they talking about the displacement in the nth second, or they are talking about the displacement in n second? There's a difference. If they say displacement in 4 seconds, I have to count from right from the beginning till the 4th second is over. Right? But when they say 4th second, then I'm not concerned up to 3 seconds. Once 3 seconds is over, then onward up to the 4th second is the S4. Is it clear? But these are the cooked equations, we say. Cooked for a special situation where acceleration is constant. Now, whenever you get a question, first thing you must keep in mind, you check whether the acceleration is constant or not. If acceleration is constant, go ahead with any one of the equation. But if acceleration is not constant, you have no other option but to go to the general equation and use calculus for this. But how to select these equations? There are 4 equations. Should I try one by one every equation? No. There is a guideline. Look, in this equation, displacement is missing. In this equation, displacement is missing. If they have not given you the displacement and they are not asking the displacement, this equation is the best to be used. You select the equation, which parameter is missing. What is missing in this case? Final velocity is missing. Go ahead for this. Initial velocity is missing. This equation is the best. And in this equation, what is missing? Time. If they're not giving you any information for time, and they're not even asking you to find out the time, use this equation. And this is a special one. Right? For that particular second, you have to do it. So selection is very simple. And once you do it for a few cases, you'll automatically come to know when you do actual question that, okay, this equation will be best or this is not. It is not that I can't solve a problem with other equations. If I'm using this equation and I want to know something I can make use of this equation in combination also. I can use equations in combination too to solve. So whatever is the situation, accordingly we have to decide, and we should take minimum time in decision making and use the equation to solve it. Is this point is all clear to you? So with this background, I'm coming to the second way of handling the motion, and that is graph. What is the importance of the graph? When I have this equation system, why I'm going for the graphical method? Do you know graph? They have one very important thing with them, and that is the overall picture of the motion. Sometimes this is also important. If I solve equation for a particular, say for time t1, I can get the information for displacement. For t2, I get the information for displacement, and so on. With the digit, I may not be able to make out that what type of the motion is this. But if I put it on graph, then I can visualize, I can even see the parameters. But one thing you all must care, graphs are not the trajectory of the motion. That's a different thing. Graph may not be the trajectory. Let me be very clear about it. What kind of the graph we normally make? Again, we have to keep one thing in mind. One is time, position, velocity, acceleration. These are my parameters. I can choose any two of them. Most of the time, we choose like this: position with time, velocity with time, acceleration with time. One can use even this: position with velocity. What's harm in it? Velocity with acceleration means one on y-axis, other on x-axis. But let's discuss about the time first of all. These are the special cases, we'll deal with them in a separate. But most of the time it is position time graph, velocity time graph, acceleration time graph. Start with the position time graph and keep some of the important features of these graphs in mind. Whenever you look at the graph, search for two important things. From where it starts, it's very crucial. Some graph starts from the origin. Some may not start from the origin. Right? Once you see, yes, time is on x-axis, x is on y-axis. Very good. Parameters are clear. How the graph is starting, because that is sometime is giving you a help to even recognize the motion. And second important thing is the nature of its variation. Look, I'm taking a very simple case. Is a straight line parallel to the time axis. What can I say regarding the motion of this body? This is a rest motion. Very good. It is not motion at all. Don't make your picture like this, that if this goes straight line like this, it means particle is going this way. No. You have to think in a graphical sense. What about the position? Position remains the same, whatever may be the time. If position is same and time is changing, it means the particle is in rest state. If I have this straight line, position is changing, but changing in a linear manner. A straight line means the variation goes linearly. When I say linear, this is a uniform motion, and how to link it with the equation. It means if this is a type of the straight line, it must be like this, that x may be a function of time, but with power 1. If it is starting from 0, no need to write anything else. But if it is starting from somewhere else other than 0, then you have to add some constant to it. This is nothing but is the equation of a straight line. Y is equals to mx plus c. That is the same version of it. But anyway, when I say x is t to the power 1, and if I get a chance to differentiate it for velocity, but all you know that when we do the differentiation, we multiply with the power and we reduce the power by 1. The moment you reduce the power by 1, you will get the power as 0. And when t is 0, it means time is gone from there. That velocity becomes constant. So we have to think this way, right? But how to get the velocity? I told you already. Velocity you can get from a straight line by taking the slope of this straight line, right? Take 2 points and do it. There is another way of looking at it. You get this angle, theta. If I get this angle, this is nothing but is a slope, which normally we write this as tan theta. But again, one thing, a point of precaution. Angle must be with time axis. You may be given this angle. If this angle is 60, obviously this becomes 30 degree. You have to take 1030 rather than 1060. So careful. Things are very clear, but in hurry, sometimes we miss these small things and we lead to a wrong answer. And let me tell you very honestly, if I have to select the answers for a particular question, I always keep one thing in mind. What are the possible errors a student can do? Student may forget, I may do a trick. I put this t here and x here, and I say, okay, this angle is 60 degree. If you simply come to 1060, you are definitely going to do it the wrong way. And 1060 means root 3. And I'll definitely put that option in all those 4 possible options. When we make questions, we always keep this in mind. What are the possible errors a student can make? And from that error, what are the possible answers we get? And we used to put those answers there in the options. And you have to be clever enough not to get entrapped. Be very, very clear that how we should take angle. We have to take angle with time, not with position. If it is 60, I have to take it at 30. You be alert for this, right? But most of the time it is not like this. But occasionally we do it to check the alertness of a candidate, whether the candidate is able to pick it up or not. If it is not a straight line, then motion is not uniform. If it is like this, a curve, motion is not uniform. Then I can talk only about the instantaneous velocity that we have discussed. How do I get it? Take a point, draw a tangent, and get the slope of the tangent, right? That we discussed. Let's not go in that. But sometimes these curves are very peculiar. If these curves are parabolas, you know, a quadratic equation leads to a parabola. If I give you a quadratic equation, I ask you to just get the graph of it. You always come with the parabola this way, that way, or maybe in any other format. It may be going like this, depending upon which axis I have taken. But if for such a parabola, you have the position given by a quadratic equation in a format of a t square plus bt plus c. That's a quadratic equation. So when I have this type of equation, I say this is a parabola. But a is a constant here, right? Not an acceleration. Please don't get confused with the acceleration. Let me put capital A, capital B, and capital C so that there should not be any confusion. But now if I go for its differentiation, once I do for velocity, this power will reduce to 1, and power of t, which was 1, will reduce to 0. There's a 1 reduction every time. But when this is now having some time with the power 1, but when I go to acceleration, even with this power 1 will go, and the power 1 now will change to 0, which means that the acceleration is not time dependent. So if it is proportional to time, I can say yes, this is the constant acceleration. So the moment you get a parabola, you can take it like this, that the variation of x with time is a quadratic and acceleration is constant. I'm giving you one simple example. If you allow a ball to fall, not from a great height, from a small height, maybe say 100 meter or 50 meter or 10 meter, you may take g as constant. I'm using a word, you may take g as constant. It means g is in fact is not constant. It changes with height. But let's ignore that change. That change is very small. We forget about it. And we say, okay, g is constant. Sometime in a question, you will find that they have given the value, take the value of g as 9.8 meter per second square. Or sometime they write, take g as 10 meter per second square. When they say that take g this much, it means we are talking about a constant acceleration. So when it is a constant acceleration and I have to draw a position time graph, if you link, I definitely going to get a parabola. But there are two types of parabolas. You may have one parabola like this and other parabola this way. If it is a xt graph, for such a case the acceleration is negative, and for such a case acceleration is positive. How can we say this? A very simple thing to test. But you know, from position time graph we can get the velocity by getting the slope of tangent drawn at various points. Let's draw a tangent here. If I draw a tangent here, it's like this, and if I draw a tangent here, it is like this. If I measure the angle, this is θ1 and this angle is θ2. Which one is more? θ2 is more. It means at less time I have more slope. That means velocity is of higher value as compared to the velocity at this point. It means as time is increasing, velocity is decreasing. Obviously this is a case of retardation, acceleration is negative. If you look at this graph, you will find the slope keeps on increasing with time. That means acceleration is positive. This is a way of interpretation of a particular graph. Now I'm coming to one of the widely used graph, and that is the velocity time graph. But if you get a question where there are many mix-up of the things, the particle was initially accelerating, then moving with uniform velocity, then it is retarding, and you have to visualize that using a graph. You want to take a help of a graph, I advise you to draw the VT graph. Why so? This is a question, you'll get the answer yourself. Look, first of all, what is a VT graph? This is the V and T. Once again, I'm taking T on the x-axis. This is normal practice. V is on the y-axis, variable. If I have a straight line like this, what can I say regarding the motion? Parallel to time axis. Is it in rest? No, 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 this time. How we understand this? One thing, remove from your mind that this, if I'm drawing the line, I'm showing you the particle is in motion. No, no, this is not at all case. You interpret it like this: time is increasing, but velocity of the body remains same. It means the body is in motion, having some positive value of the velocity. So this is a case of a uniform motion, right? Can I show particle in rest on the VT graph? Is it possible? Possible hai? Yes, possible hai. You draw the line exactly on the time axis. But if I draw a line on the time axis, I'm indicating that yes, this is the origin, zero velocity, and with at all times the velocity remains zero. If this is the case, I can say yes, this is the rest position. What happens when this is a line? Velocity is there, but this time the velocity is positive, and in this case the velocity is negative. What is the meaning of the negative velocity? It's not retardation. The uniform velocity means acceleration is zero. Even in this case, the acceleration is zero. No, it's uniform, 100% uniform, because velocity is constant. That is based on the direction aspect. Suppose in my set of parameters, I take this as my origin, and this I take as a positive direction. Anything going in this direction is having positive velocity, and when particle is going in this direction, it doesn't mean that particle should be here. No, particle may be here, but is going in the opposite direction to what positive I have taken. I could have taken this direction as positive. then anything in this direction will be taken as negative. That is relative. So when I say the velocity is negative, doesn't mean it is retardation. If it is same value at various times, you can say yes, the acceleration is 0, and it is also a case of a uniform motion. All right, is this all clear to you? Now, if in the VT graph I get a straight line which is inclined like this, that means the velocity is increasing. And how should I interpret this? I told you even the xt graph, if this is linear, it means I must have something like this where I have t to the power 1. Nothing if it is starting from origin. If it is starting from somewhere else, you must have something with this as a constant. But anyway, if v is proportional to t to the power 1, the acceleration is going to be independent of time. The moment you go for its differentiation to find out acceleration, dv by dt, power 1 will vanish. You have to take it as k t to the power 1 minus 1, and 1 minus 1 is 0. So it means the acceleration is constant. So I can say this is the case of a uniform acceleration, not uniform motion. Uniform acceleration or accelerated motion with constant value. If it is this way, acceleration is positive. If it is this way, it is a negative acceleration. Acceleration is negative. The notes given to you is having a very well planned graphs there. You can just go and check that. Anyway, I can interpret this way. Look, what information I'm able to draw from it. Very first, velocity time graph gives me the information for velocity with time. And if I go for the slope of the straight line, that means I choose once again the 2 points like this and take the acceleration as v2 minus v1 divided by t2 minus t1. Or even if I take the angle theta and take this as tan of theta, I'm able to get the information for acceleration. So I'm getting the information for acceleration also. Can I go for the displacement on the upper side? Possible hai? Hai. But look, if I have a VT graph, say this one, a simple one, VT graph, and you able to get the area under the graph towards the time. Once again, I'm very specific for this, that you have to calculate the area, but towards the time axis, not towards the velocity axis. If I get this area, this is nothing but is a measurement of displacement. How do I get it? This is a triangle. For triangle, the area I know is half base into height. Whatever the value given, you can take this as base, and this will be the height. You can calculate half base into height. If it is trapezium, use the formula for area of the trapezium. What is that formula? Half sum of parallel sides multiplied by height. But if it is a circle, then a part of the circle, 100% circle is not possible. If it is something like this, then is a quarter of a circle. Can I say 1/4 of the pi r square? Never use it. It's wrong. Yes, you have to be careful. See, for competition, this is very interesting. There are certain points where the formula is not applicable. We know this. As a teacher, we know this. Once we know this, we always try to trap our students on these points also. Because we have to select who is able to get it correctly or who is using a simple way. But see, a circle is having a radius which is the radius in all the directions. I can't treat this as my radius because it's time axis. Because if I'm taking this as radius, this is going to be velocity. Dimensionally, they are different. How can they be? This is treated as a symmetric ellipse. And you will understand ellipse has an area pi AB. You can note this. This is a special case. Pi AB, where A is the semi-major axis. See, ellipse has one side which is the longest side. Half of that will be called as a semi-major axis, that is A. And there is a smallest side, and half of that is called the semi-minor axis. You will study ellipse also in maths in detail, but for this particular case, you remember this formula directly. So if it is ellipse or 1/4 of ellipse, the area is going to 1/4 pi AB. You can treat this as A, or you can treat this as B. It doesn't matter, because you have to multiply the two. So area of this is not 1/4 of pi r square. It is 1/4 of pi AB. These are few things you keep in mind, right, to find out the area. So by knowing the area, I'm able to get the displacement also. See, if I have a VT graph, I have a possibility going towards the displacement. I have a possibility going towards the acceleration. For displacement, I have to get the area. For acceleration, I have to get the slope. Right? So I have both the flexibility there. So if I have to draw a graph, if in a particular question I need to think about the motion, I prefer to draw the VT graph. Although you can draw the acceleration time graph also, position time graph also, but VT graph is more informative as compared to the ones, right? Third graph, position acceleration time graph, AT graph. This also is very important. AT. If I have a straight line going parallel to the time axis, what can I say regarding the motion? This time. Don't be afraid of it. Say whatever you have in your mind. Very good. It's a case of the motion where the acceleration is constant, moreover the acceleration is positive. If I have this straight line here, it's a uniform motion. Acceleration is 0. If I have the same straight line on the negative side, I'd say the motion is with constant acceleration, but this time it is not positive, it is negative, or rather it is a retardation. Got the point? If it is a straight line like this, or maybe a parabola, all the cases are the cases of a variable acceleration. All right? One important thing. On the AT graph, that means acceleration time graph, if I get the area, what information I expect? In the same line, I get the change in velocity. Please remember, on VT graph, if I was getting an area on VT, I told you that this is nothing but is a displacement. Displacement is final position minus initial position. So area on AT graph is nothing but is the final velocity minus the initial velocity. That means I'm talking about the change in velocity. If it is 0 initially, very fine, it's a velocity, but it may not be, because velocity I can't show it here. One more thing. If I have, say, a graph like this, where I have a positive side for acceleration t and negative side also, please treat this as a positive change in velocity and this as negative change in velocity. It means there the velocity is increasing, and in this part the velocity is decreasing. The change is positive and this negative. Same case here. If it is on the positive side, the displacement is positive. If it is on the lower side, the displacement is negative. I have to care for the plus minus sign also. But all these parts are clear to you. See what I so far have given you. I'm quickly revising it so that we can jump to the questions. First point, kinematics is a branch of study of motion when I'm not dealing with the cause of it. It's only a parametric relations, either by equation or by graph, which I am handling. Who is responsible for it? What type of the force? Constant, variable, no concern. Two ways. One equation, other is graph. For equation, I have two set of equations. One, general equation, which are basically definition based, either in differential form or in the integral form. Other method is method of graphs. I gave you some of the important features of the graph. For position time graph, for velocity time graph, for acceleration time graph. There are many other aspects associated to it. We'll do all those while handling the questions. But one more thing for graphs I would like to tell you. Sometime we select the correct answer by rejecting some of them. Do you remember that 50-50 type of a thing? If you can reject some of the options, it becomes even simpler for you to come to the correct answer. Look, this type of the graph is not possible. What's wrong with it? From this to this, time is increasing. But for this part, time is decreasing. ऐसा तो कभी नहीं होता बेटे. Practically it is not possible. There's another way of looking at it. Some say like this: at particular time, I have two positions. It's also not possible. Is it possible that you are sitting here and you are also sitting at your home? Practically not possible. Theoretically, we may say, right? Not only for position time, it may be for velocity time also. Look, I'm making a graph. I say specifically it's a distance traveled with time. Say even this graph is not possible. What's our minute? Distance covered is never decreases once it acquires a value. But had it been displacement, this may be a correct graph. For example, a particle is going in a straight line and then returns back. As far as the displacement is concerned, this is the displacement. But if I talk about the distance covered, this much plus this much. Say for example, this is 100 meter and this is say 60 meter. If I have to write the value of the distance covered, I'll write this as 160. But if I have to write displacement, I will write plus 100 and minus 60. That makes it 40 meter only. Right? So displacement may decrease with time, but distance will never decrease with time. So these are some of the aspects we have to care. If I say this is my origin and this is the displacement time graph, even this is not possible. No, what is wrong? Displacement at the starting point is always zero. Because what is displacement? Final position minus initial position. At starting, final is also the initial. So this graph has to start from origin. So if you care for these small things, you can reject some of the graphs. Or if I have, say for example, the velocity time graph and I get a straight line like this, even this is not possible. Once again the same. At one time, you cannot have the many velocities. You have only one velocity possible. So you can reject some of the graph if it is given, and on the basis whatever are left out, then focus on those and try to select the right one. Now I'm giving you some of the shortcuts. Do you like shortcuts?
Yes, sir.
Everybody likes shortcuts. But shortcuts are equally risky. Before telling all those things to you, why are they risky? Because shortcuts are basically those tricks which has certain initial conditions to be fulfilled. So if you are using a shortcut, you must care for their conditions under which that shortcut is applicable. You can't try shortcuts everywhere, in every situation. It is not possible. If traffic is fast, and you try to cross by shortest path, it is obviously going to be dangerous. One should be very careful, right? So I'm giving you some of the shortcuts. These shortcuts are nothing but they are the cooked final relations which you should remember, and that will help you to get the answer in a faster manner. But when it is faster, then you have to be alert, extra alert. The same way if you drive a car at a high speed, then you have to be extra careful because your response time has to be fast, right? So बेटे मैं बता जरूर रहा हूँ, but with the condition that you have to use them only once you are convinced, yes, the conditions are fulfilled, then only go for it, right? It is not all prepared by me, it is prepared by the pupil. And I start by giving the honor to Galileo, Italian physicist, mathematician rather. And that is with the Galileo method of odds. And prepared at that time. Method of odds. What's that? If initial velocity is 0 and acceleration is constant, these are the conditions. One should be careful once you start using it. Confirm, is it that the initial velocity is 0? Acceleration is constant? If yes, go for it. What he told us, that if you divide your motion in equal time intervals, say for example, I say the first interval is of time t, the second interval is also of the time t, third interval is of the time t, then what he said is that the displacement of the particle is in odd multiples. That means 1:3, ratio 5, ratio 7, and so on. Where can I use this? Oh, very simple. Take a particle and you allow to fall it from a great height. You might have visited some of the hills and you might have dropped a stone, though it's very risky and the stone may hit anybody. But if you're sure that nobody is there, you throw a stone, you can even find out that approximately what is the height at which you are standing. Look how we get it. If I take g as 10 meter per second square, conditional, and time interval I choose as 1 second, then you know how it's divided: 5, 15, 25, 35, 45, and so on. It means in the first 1 second, it will cover a distance of 5 meters. In the next 1 second, it will cover a distance of 15 meters, 3s. And then 25, 35, 45. If you are aware of it, at least you can make out what is the odd option in the given possible 4 options. You can rule it out. It's not possible if you know this thing. But had it been a case of g 9.8 meter per second square, there's small change. And how one should remember the change? Instead of 5, I get this as 4.9 meter. This is in meter, right? Can you expect what will be the value here? Either you multiply this by 3 or do one thing. See, in this case, there is a difference of 0.1 meter less. In this case, it is 0.3 less. 14.7 meter. How much less here? 0.5. 0.5 means this is 5. It's a way of doing the calculation. And you should be good in mathematics and fast also, and intelligent also. Mathematical steps are with guideline, but the route you choose is your intelligence. Say, for example, if I ask you to multiply 19 by 15 and divide by 2, can you give me its answer? I'm just calculating the time. Do it fast. देखते हैं कितना fast करते हैं. 5 seconds are over. 10 seconds are over. 1, 2.5. You have given it in 13 seconds. Right? Anyway, one can multiply and divide by 2. It doesn't matter much. But we, those who are doing competition, in competition, even one mark is very important, as you all know, right? Competition is a war. Sometimes we say that use all methods in war, and same we do. It's like a war. This competition, we have to get position. Instead of multiplying 19 by 15, I multiplied 20 by 15. I'm not doing any calculation here. 20 by 15 gives me 300. Divide by 2, 150. How much extra I have taken? 1. 115 by 2, 7.5 minus, that gives you 142.5. Is a way, I'm just suggesting way to you. 19 into 15 divided by 2 can be handled as 20 into 15 divided by 2, that is 10 into 15, 150. How much extra I have done? 1 in 15 by 2, that is 7.5 extra. Even the people do like this, 7.5, reduce it. 142, how much more I have done? 0.5, so it should be 142.5. If you can try all these things, good. If you are good in trigonometry, if you are good in table, it is an extra help for physics, numerical based questions. So do revise it. Sometimes it becomes a problem for the students to even go for these type of the calculation. Though there are other techniques, your mathematics teacher will tell you, but I keep telling you wherever we find that's convenient. So anyway, this is the idea. This gives me a picture in mind. If I allow a stone to fall from a height, in 1 second it will cover a distance of 5 meters nearly. The next second 15 meters. And interestingly, if I try to collect these distances this way, I get a pattern. Look, 5, then what I have? 15 plus 5, that's for 2, 20. Then this is 20 and this is 45. 25 and this is 20. This is 45. You know what's the pattern? This is 5 multiplied by 1 square. This is 5 multiplied by 2 square. This is 5 multiplied by 3 square, and so on. This is the cumulative distances. I'm not doing any trick. It's always mathematics. It's always because you have those equation s equals to ut plus half a t square. So it's a consequence of it. So if they ask me to compare the distances traveled in 3 seconds and say in 5 seconds, I can make use of this. Right? Cumulative distances up to 3 will be 5 into 3 square. And cumulative distances in 5 seconds will be 5 into 5 square. So it's 9 by 25. No need to write even anything. So this is a quite useful, given by Galileo. It's not our, and it's very, very helpful, right? Now, there is another version of it. And what's that? Instead of dividing the motion with the same condition, that means the initial velocity is 0 and acceleration is constant. You divide the motion, but this time you divide not by time interval, by the displacements you have. Suppose I select the displacement to be s every time. First s, second s, s, and so on and so on. But condition is initial velocity is 0 and acceleration is constant. If time taken in this is t, I'm writing in a very specific way. T multiplied by 1 under root, take only positive values, minus 0 under root. You'll laugh on me. What's the use of writing this? This is t. You'll get an idea how much time is taken for this. T root 2 minus root 1. How much time for this? T root 3 minus root 2. This is a time interval relation. This sequence you have to keep in mind, and always in search of those type of questions where you can apply them, apply it fast. Right? It is all is from the mathematics. Nothing. This is not कोई जादू नहीं है. Equations के consequences हैं बेटे, because we have these equations here. There is a category of the question where they are asking for the average velocity. They talk about the average velocity. In fact, I'm using this vector here. I hope you are aware of it, that this arrow on the top means is a vector with a direction. This is the total displacement. I'm using the symbol of summation and dividing it by the total time. Total displacement by the total time. That's what we call as average velocity. But when I say displacement, I have to keep one thing in mind, that the displacement on the positive side, once I selected it, then any displacement in the opposite direction is to be taken as negative. Time intervals are never negative, so they are positive always. So total displacement by total time is average velocity. But there are certain cases here. One case. If I have a situation where acceleration is constant, if acceleration is constant, then your average velocity is going to be u plus v by 2. Right? It is a vector also, but I'm doing it now for the 1D. If you are sure that the acceleration is constant, both in magnitude as well as in direction, you have to take average of that, or numerical average of the initial and final velocity. That's all. No need to go for the displacement calculation and timings and all that. There are cases where they divide the motion, saying that for half of the time the particle is running with the uniform velocity v1, and for rest of the half it is running with the velocity v2. Then what's the average? Average is v1 plus v2 by 2. But if it is divided by time, it can also be divided by the distance. Then the formula is different. Let me write the formula here. If a body is going in the one direction, for half of the displacement it keeps the velocity v1, and for the second half the velocity is, say, v2. Then what's the average? For that, if you can remember this formula and use it directly. It is from the same one. You can calculate the total displacement is going to be s. The time taken here is equals to s by 2 divided by v1, and for this is s by 2 divided by v2. At time, divide, you'll get this automatically. If you can remember, fine enough, use it. Right? So these relations can be used directly. But we have to care for the condition here. Its acceleration is constant. In this case, division is done on the basis of time, equal time intervals. In this case, it is the equal displacement which we have to take. Right? Now what I am giving you is the most important of this chapter. Do you know acceleration constant? I told you that you can use v equals to u plus at, s is equals to ut plus half at square, v square is equals to u square plus 2as, or sn ko bhi, let's keep that. These are three important equations which we can use when the acceleration is constant. But you know, all these are the vector equations. How I can say this? What is v? Final velocity, not the final speed. Initial velocity, acceleration is vector. And what is S? Not the distance traveled, it is a displacement traveled, and all are these vectors. And when you are dealing with vector, even in one dimension, you have to care for their directions. And direction, or we call sometimes as sign conventions, are very crucial. And most of the time, people do error in solving the problem. I'm taking a problem with you, and I'm giving you two methods. One which you have done in your earlier classes, and one you are going to learn in your 11th standard. Let's keep one problem as a sample problem to understand the sign convention, and please feel free in discussing why I'm taking it as positive or negative. You have to clear all your doubts on this plus minus, because this is the most important from my point of view. I take a very simple case that there is a building which is 100 meter in height, and from the top of it, a person throws a ball with the initial speed of 20 meter per second. The ball obviously goes up, reaches at the top, and returns, say, to the ground. This is a one-dimensional motion. Please forget about this small gap. It is one-dimensional motion this way and returns like this. So it is to be overlapped like this, but to show it separately, I'm giving you this way. To make the thing simple, I'm saying, okay, keep G as 10 meter per second square. But you have to give me how much is the total time taken by this particle or body to go up and return to the ground. Now, to handle it, I have two methods. First, method 1. But this method is based on the concept of acceleration and retardation. Acceleration means I should take G as positive, and if it is retardation, I should take this as negative, right? Plus minus sign is quite obvious. But in this method, I have a compulsion, and that is, say from A to B, B is the topmost point, A is the initial point, and C is the final terminal point. I have to divide the motion. Why should I divide the motion? Because for upward journey from A to B, I notice that the speed of the body keeps on decreasing, because the top it must come to rest before it return to the ground. It means if the speed is decreasing, I should take G as minus 10 meter per second square. You agree with me? Why I'm taking negative? Because I find the speed of the body is decreasing, and speed decrease means that this acceleration is negative, it is not positive. It is a retardation rather. Minus 10 meter per second square. Let's calculate the time for this interval, saying that this time interval is T1. Once I take this as negative, I need not to take any negative sign with any other parameter, whether it is initial velocity or displacement condition. Let me write what is the initial velocity for this part of the motion. Initial velocity for this part of the motion is 20 meter per second. Take it as positive. Why positive? Not because it's going up. It's because for this method I have to keep everything else positive. What about the final velocity? 0. For this, no need to think of plus minus sign, maybe plus minus or whatever it is. And I have to get the time. Can you tell me which is the best equation out of the three? First one, because distance I don't want to know at this stage, and distance also is not given to me. How much is the distance traveled in upward direction? So best equation is this one. Let's use it. Final velocity is 0, initial velocity is 20, acceleration is minus 10, in my case is g, right? And time is t1, so t1 I get as 2 seconds. Look, it's a checkpoint. If I get time as negative, it means something wrong has happened. Time interval cannot be negative. This is your checkpoint. Whenever you find time negative, you go through it, maybe some error might have been done. But before I proceed for this journey, I want to know how much is the displacement, and I prefer to use a relation v square is equals to u square plus 2a s. I'm selecting it deliberately. I want to use all the equations. Final velocity 0. Initial velocity 20. Square of that will give you 400. A is negative. Multiplied by 2 will give me 20. And let me say this is s. And s comes out to be 20 meter. You might be thinking that this is an additional information. Why you are getting it? But this I am getting in order to get the time interval for B to C. Right? Now come to this part, from B to C part. But if I think it of that from B the body is coming down, what happens to its speed? Is it increasing or decreasing? It is increasing. So it means what's the role of the G? Positive. Is the acceleration is increasing the speed, that means it's positive. So for this journey, I should take G as plus 10 meter per second square. You got it? Once I select this, need not to think of a negative sign with any of the other quantity. But now I know from this information that displacement is 120 meter, because I have calculated this distance. Of course, this also is to be troubled. I'm using now the formula s equals to ut plus half at square. S 120. Why I'm not taking negative sign here? It cannot be negative. Not because it is going down, you should take this as negative. Mixing nahi karna. That is the daily thing. U, can I take 20? No. My motion starts from B. So initial velocity of the second part of the motion is final velocity of the first part. It's a link. Final velocity of the first part becomes the initial velocity of the second part. So initial velocity here is 0. You may say this is u2. So this is 0 plus 10 into t2 square. 0 is out. This go here. 24 and t2 will be equals to root plus minus 24. Should I take minus root 24? Do you allow me to do it? No. So this is to be ruled out, that this is something which is not feasible, not possible. So only option I have plus 24. So in first part I got the time interval as 2 seconds, and for the second journey I got this as root 24 positive. So my total time will become 2 plus root 24 second. My aim is not to just get the answer, but this is what the correct answer is. You can solve it to find out the what exactly is the value. But is this part is clear to you? I'm repeating it again. If you are doing it by this method and you have upward as well as downward motion, then please divide the motion in two parts separately. For upward journey, G is negative. For downward journey, G is positive. And rest every other thing is positive. This is one way of doing it. Now I'm giving you the second method, and you have to handle it carefully, because second method is the baseline for the 2D motion. When you talk about or deal with the projectile motion, we have to use the second method. But there is something which is mixing up kind of a thing possible. So please don't go for this, right? This is second method. But a second method is based on what we call as vector method. Yeah, this is even the preferred one. Means you can make any one of the method as your favorite method. A one which is favorite one, with that you can do the things in a faster way, even if it is lengthy one, right? But I'll advise you this, especially for this type of a case. My now look is different. Same problem, 100-meter building, body going up with 20 meters per second, going up and returns to the ground. Okay, forget for a minute that all these informations we know, right? Though not possible, but let's handle it. But when I'm dealing with a vector method, I have to make one decision in the beginning. Should I take the upward direction as positive or downward direction as positive? Normally we take upward direction as positive and downward direction as negative, but you can do other way around also. It is convention. Convention means this is my way of taking it. A person can say, okay, no, I'll take upward as negative and downward as positive. He's also correct. That is his convention. But physics and mathematics will give you the same way of answer, right? Look may be different. Look may be different. I'm taking it upward, anything is positive, and downward anything is negative. But anything means all velocities, accelerations, or even the displacements. Very clear, no ambiguity that we have to have positive, negative only for acceleration. Why should we take it only for acceleration? We'll take it for everything. Now I'm writing the parameters. Initial velocity. I'm specifically initial velocity is positive 20 meter per second. Because what is my initial point? A. And my final point is C. This is the advantage of this method. You need not to bother about B. What is happening in between, I am not concerned. My initial point is A and my final point is C. Which mein kya hua? Oh, I'm not concerned with that. But is this positive is clear to you? Why this positive is this time? It is because it is in the upward direction. Just because of this. What about G? G is acceleration due to gravity. It is due to the gravitational force, which means the body always is pulled in the downward direction by the earth. See, I'm using a word. Earth always pulls the body in the downward direction, whether it is going up or coming down. Earth has one simple, clear-cut view. Due to the gravitational force of attraction, there is a force of attraction and body is pulled down. If it is pulled down in downward direction, you should use negative. If I've taken other way around, I could have written it positive and this is negative. And it's not going to matter. Right? In the whole equation, if you change all the signs, it's not going to matter. But what about the displacement? For displacement, there's a one simple rule. Start from the initial position and go to the final destination. I'm giving you another example just to highlight this. Suppose in one morning, you start from your home and your destination was your school, but in between you get, say, advice from your teacher that you have to come with a practical file in physics and you forget to arrange it, then you have to rush towards the market. You purchase the book and come to the school. This is the actual motion you have done. But if I have to talk about your displacement, I need not to take this market into the account. I'll simply say, okay, your initial point was H and your final destination is S. It means your displacement is from H to S. It means I have to take initial and straight to the final. In between, I'm not concerned. But maybe your parents may be concerned that you are going straight to school or going somewhere else. But physics says displacement is from H to S. And in my case, initial is A, final is C. It is downward, 100 meter. I say downward means minus 100 meter. I need not to do anything. All the three. But plus minus are crucial in this. Let's see whether we get the same answer or we get some different answer. Because this time I'm not dividing the motion, I'm doing it with one equation. Using one relation, S is equals to ut plus half at square. Displacement is minus 100 Initial velocity is 20 t minus half 10 t square. Check. Plus minus sign. Is it according to what we have taken? S is negative, U is positive, A is negative. That we have done, right? Let's solve it. 0, 0 I can remove. 2 will go on that side. Minus 20, 40 minus t square. My quadratic equation is t square minus 40 minus 20 equals to 0. You can't think of the fraction easily. You can't do it from this. So let's use a discriminant method to do it. Minus b, that makes it 4, plus minus under root of b square, that makes it 16, minus 4ac. 4a is 1, c is minus 20, that makes it 80, and divide by 2a. A is 1. I think it's okay. Minus b plus minus under root, right? That's what we have done. So t will be equals to 2 plus, this is 96, divide by 2. 2 already have divided here. Let's take this 2 under this, under root. 2 plus root 96 divided by 4 is exactly 24. So there are two answers now. 2 plus root 24 and 2 minus root 24. Shall I take this answer? Why? Not because of this. Whole of it. Look, 24 is nearly 5. 24 is nearly 5. So 2 minus 5 will give you nearly 3. Minus 3. Minus 3 is not allowed. It is not because we are getting a negative here. It is because whole of it is negative. That's why it's rejected. And that is your answer, which is perfectly matched with this one. I have just given one example to give you an idea that why we should take G as negative throughout. And look at the advantage we have. Here we have to divide the motion in two parts in previous case, but in this case, you need not to divide the motion in two parts. So whenever you have a motion upward, downward together, you prefer this vector method. And if it is one direction, choice is yours then. Both are equivalent, right? But you have to master this. For 2D motion, you have to have this with good understanding how to do it. So plus minus sign is to be taken care of. Is this aspect is clear to you? Another important aspect. Another important aspect. Shall I remove this? Nowadays, from 1D motion, most of the questions are from the relative motion. What is the relative motion? Relative motion. This is the most favored topic of this chapter. Means you are most likely to get the question from this portion. But let's understand the concept. Though it's a two-dimensional case more, or three-dimensional maybe. See, all the time we are not making an observation from rest. Suppose there is a body A and it is in motion having velocity VA. I'm putting a vector here, just I'm making it general, right? This is even for 2D. There's a body B and it has a velocity VB. All right. When I say this, I'm observing from somewhere and I'm keeping myself in rest. Though it's a big question. If I'm standing here and I'm observing the two bodies in motion, can I treat myself in rest? For this setup, okay. But if it is seen from outside, then I'm not in rest, right? But anyway, let's keep the boundary. And I'm doing the experiment in this room and I'm in rest. I find that, okay, A is going this way and B is going this way. Suppose I position myself or any observer on the body A itself. So definitely I'm in motion now. If you ask me, sir, what is the velocity of the B? Velocity of B with respect to A. See, I'm reading it as of B with respect to A. Language is this. Then according to Galileo Galilei, the Italian physicist, has done a wonderful work on this kinematics and done a lot of experimentation also. Was a good experimentalist and gave an idea of a pendulum clock. And he got this idea when he was standing with his mother in a church and watching a chandelier going from one position to another position. And that little boy was observing that sometime its amplitude is more and sometime its amplitude is less. But time interval is same. Do you know how he counted the time? From his heartbeat. Like little boy is nothing to do with the prayers going on in a church. See, all of us, we remember our childhood. Then when we used to go to temple or gurdwara, we most of the time are looking for then when we are going to get prasad. What is preaching and all that thing is not known. So he was counting it by counting his heartbeat, and he found that yes, amplitude has nothing to do with the time period. And then later on, this idea was converted into the pendulum clock. Galileo has given this transformation equation also. He said that if this is the situation and you are interested for the velocity of the B with respect to A, you should take this as velocity of B minus the velocity of A. It means reference velocity is to be subtracted. We'll take it in 2 dimension later on, or maybe some other person will take, but let's do it for 1D this time. There are 2 situations possible. You may have B going in this direction and A also going in this direction. And my observer is at A. Please take it as an imaginary observer. No need to sit on the particle in motion. This is only thought. If this is a situation, I'm looking for the velocity of B with respect to A. As per this equation, it will be velocity of B minus the velocity of A. Agreed? But look at some other situation. It may be like this, that they are going away from each other. Suppose B is going in this direction and A is going in this direction. This also is possible. Now if I have to write VBA, my formula remains the same. VB minus. But if I have taken this direction as positive, I should take this direction as negative. I should write this as minus VA, and that comes to VB plus V. You might have noticed while traveling in a train, when other train on the parallel track is running in the opposite direction, you always feel that this train is going very fast and our train is going very slow. What happened to our train? You feel that you should go to the driver and just shout on him that why he is moving the train with a less velocity. No, it is nothing like that. You are observing it for the case when the train is going in the opposite direction. Had it been a case going in the same direction, you might have noticed even that train is going slower, because the relative velocity is the difference. So this is only the observation made by somebody who is in motion itself. So whenever you have 2 particle situation, we have 2 ways of handling it. Either you write the equation for each particle and merge the 2 equations, or you write one common equation. What's the advantage? See, when I have 2 particle motion this way, or even for the 2D, I can use the equation in this format. Suppose I take A with respect to B. Final velocity of A with respect to B should be taken as initial velocity of A with respect to B, acceleration of A with respect to B into t. Or it may be vice versa also. Velocity of b with respect to a to be taken as initial velocity of b with respect to a and acceleration of b with respect to a also. But I have not used it for t. Why not? Time is absolute. Time is absolute. If you have your watch, either you are in train or you are outside in a platform, your running time is same. But it's not 100% true, let me tell you. After Galileo, Einstein came and he gave idea about the relativistic time. But that is applicable only when the velocity is very high, close to the velocity of light. So we are not touching that part. We are dealing with only those cases where the velocity is very, very small. You know what is the velocity of light? 3 into 10 to the power 8 meter per second. That's a very high velocity. And how fast you can run, depending upon the person who is making you to run, right? Maximum, you can have a velocity 10 meter per second. You know, 10 meter per second is 36 kilometer per hour. That's a fast, maybe a normal bus speed. It's quite high for a person. So 10 meter per second, and the velocity of light is 3 into 10 to the 8 meter per second. So keeping that in mind, I'm not going for the relativistic concept. So t I'm taking as an absolute time for my purpose. It is not exactly absolute. Exactly absolute. But similarly, I can go for the displacement like this. Initial velocity of a with respect to bt plus half acceleration of a bt square. Once again, no relativistic concept for time. Same you can write VAB whole square, UAB whole square minus 2AAB into SAB. Questions are same, but only thing that I have written it for the relativistic case. Since this is very important, let's do one question based on this. Do I have the question on the PowerPoint? It's there, but I'm just giving the question itself on the board. One more minute only. So let's then not go for that more details of it, because question with you will not be that easy. Anyway, see, when you take these type of things, one thing which we have to care that for 1D it's plus minus that will do, but when it comes to vectors, then appropriate direction has to be taken care of, right? So since I have to stop at this stage, any question from anywhere? Or you can, if you find any question, you can ask. So fine. Have you understood everything? Sure about it? Okay. You're free to ask any question on any other part. Okay. Shall we stop now? Okay. One question is there. Yes. Some so audio is not clear. I'm not getting your answer. Can they write somewhere text side? Anyway, tell them that they'll send the question to me. That I'll answer then in a proper manner. So anyway, right, बच्चों? बड़ी मुश्किल तो नहीं लगा ये? हाँ? Are we able to get it? There are many folds of it. So go through your book. I have given one PowerPoint presentation also with all these details there. but it's better to do it on the board. So sometime on this PowerPoint presentation, we are not able to make a sequential format of it. तो बेटी दे मिल जाएगा ना, हाँ हाँ इनको इनको दे दीजिएगा। तो उसमें मैंने कुछ क्वेश्चंस लिखे हुए हैं, और आपकी ही बुक में भी हैं कुछ क्वेश्चन, लेकिन कुछ एरर्स भी हैं आपकी बुक में जो आपको बुक दी है। तो यदि कोई डाउट होगा ना तो बेटे मुझे भेज देना, तो यहाँ जो भी कोऑर्डिनेटर हैं उनको दे देना, तो दे कम टू मी एंड देन आई विल आंसर इट, राइट, बैक टू यू। सो बट एनीवे इज वेरी इंटरेक्टिव, यू पीपल वर अंडरस्टैंडिंग इट। हाँ, कैलकुलस मैंने करा दिया, कैलकुलस अपने पढ़ा नहीं हुआ, पढ़ लिया कैलकुलस, तो वी आर एबल टू गेट इट देन। हाँ, फिर कैलकुलस में थोड़ा सा प्रॉब्लम आता जरूर है बच्चों को, उनको तो चेक किया कैलकुलस करा दिया पहले, है ना, तो उससे आगे बहुत बड़ा फायदा होगा। It is 3:15 to 5. Yes, sir. That's it. कुछ और तो नहीं. You are presently in 11th, all of you? All 11, studying in 11th. Which schools? That's some indicator or pointer that is there.
Actually, this is uploaded in the software, so I will manage it to say next.
This will not come. इधर उसमें तो नहीं है. Just a minute. Hello children, today we will be studying about trigonometric ratios, identities and trigonometric equations. Right? Now all of you are aware of the system of measurement of angle. There are two ways in which you can measure an angle. One is the sexagesimal system of measurement and the other is circular measure. These are the two measures which are used. All of you know in sexagesimal system, is that degree measure. One right angle is equal to 90 degrees, right? 1 degree is further divided into how many minutes? 60 minutes. And further 1 minute is divided into 60 seconds. So this is the first measure which we use in our initial classes. One right angle is 90 degrees. 1 degree is further divided into 60 minutes. We use 1 slash for it. And 1 minute is further divided into 60 seconds. But now in your senior classes, we use the other measure that is known as the circular measure. Circular measure. Now what happens in circular measure? What is a circular measure? How you measure an angle? It is measured in radians. But what is a radian measure? Like suppose we take a circle. Suppose we take a circle, right? This is a center and there is an arc of length L. Arc is of length L and the radius of the circle is R. Now who will tell me what is this angle? Central angle which an arc subtends at the center of the circle. The length of the arc is L and the radius is R. What is the angle subtended at the center? How many radians? L by R. So this angle theta in radians. Theta in radians is L by R. Now what is 1 radian equal to in terms of degrees?
180 by pi.
1 radian comes out to be 180 by pi degrees. See, you can convert one form into another. What is the formula to convert it? Now suppose you take a circle. This is the diameter. What is this angle? You know it is 180 degrees. Now if the radius of the circle is R, the circumference of the semicircle, in fact it's not a full circle, so we take this arc length. That is what? Pi r. And when you will divide this pi r by the radius, you get pi radians. So this is a formula by which you can convert radians into degrees and degrees into radians.
further. Oh, it's not, yeah. And 1 radian is equal to approximately 57 degrees, 17 minutes, and 45 seconds. It is not equal to 60 degrees. The reason is, see, when you want 1 radian, this will be equal to r. The arc length will be equal to r, and this chord will be slightly less than r. So this angle is less than 60 degrees. Now there are some basic formulas which we have already done in your previous classes. First is, these are Pythagorean identities which you are all clear with. Sin square a plus cos square a is 1. 1 plus tan square a is sec square a. 1 plus cot square a is cosec square a. Now, one very important thing you must understand is that whenever you split an angle with the help of pi by 2 radians or 3 pi by 2 radians, the T ratio will change. And whenever you split an angle with the help of pi radians or 2 pi radians, the T ratio will remain same. And the sign of the value you can determine by the quadrant in which it lies, right? This is y-axis. This is first quadrant, second quadrant, third quadrant, and this is fourth quadrant, right? Now in first quadrant, all T ratios are positive. All are positive. In the second quadrant, only sine and cosec. Only sine and cosec are positive in the second quadrant. Sine theta and its reciprocal are, cosec theta. Reciprocal of sine is cosec. These two are positive. The remaining 4 T ratios will be negative. Which one? Cos, sec, tan and cot. They will all be negative in the second quadrant. Now when you come to third quadrant, tan theta and cot theta are positive. The remaining 4 will be negative. And finally here, cos and sec, these are positive. The remaining will be negative. This is clear to you? Now further, these formulas are known as addition formulas. Addition formulas are basically 8 in all, and you have to remember these. These are known as addition formulas. First one is sin A plus B. What is sin A plus B? Sin A cos B plus cos A sin B. What is sin A minus B? Sin A cos B minus cos A sin B. Similarly, you have formulas for cos A plus B as well as cos A minus B. Cos A plus B is cos A cos B minus sin A sin B. And finally, cos A minus B is cos A cos B plus sin A sin B. These formulas you have to remember. And what about tan formulas? Tan A plus B is tan A plus tan B upon 1 minus tan A tan B, right? See these formulas. Fifth one is tan A plus B, tan A plus tan B upon 1 minus tan A tan B, and sixth one is tan A minus B, which is tan A minus tan B upon 1 plus tan A tan B. The previous formulas, second, third, fourth, are given here. They are all addition formulas. Besides this, you can have 2 more formulas for cot A plus B and cot A minus B. Now comes these 7th and 8th formulas, which are also very often used. These formulas are see the formula number 7th. What is this formula? Sine of A plus B multiplied by sine of A minus B, right, is equal to what? Sine square A minus sine square B. and you can convert it in terms of cos also, because the moment you write sin square A as 1 minus cos square A and sin square B as 1 minus cos square B, you will get its other equivalent, cos square B minus cos square A. And what about cos A plus B and cos A minus B? Yeah, cos A plus B multiplied by cos A minus B is cos square A minus sin square B. Remember, the second term here is sin, right? And still this can again be converted into its complementary form, right? Now comes multiple angles. Sin 2A is 2 sin A cos A, or 2 tan A upon 1 plus tan square A. Sin 2A is 2 sin A cos A, and it can further be converted in terms of tan, which is 2 tan A upon 1 plus tan square A. And how can you derive it? It is very simple. In formula of sin A plus B, you put A and B equal to theta. You get value of sin theta, right? If sin A plus B is sin A cos B plus cos A sin B, we all know this formula, right? In A and B, if you write theta, so what is sin 2 theta? Sin 2 theta is 2 sin theta cos theta. Now this can further be converted into its tan form. What you can do is divide both numerator and denominator by what? Cos square theta. Divide by cos square theta. So when you divide by cos square theta, you get 2 tan theta. And here in the denominator, you get sec square theta, 1 by cos square. And sec square theta can be written as 1 plus tan square theta. So our main emphasis here will not be proving these formulas. So the formulas are given here, and you can refer them from your book. But the main emphasis is on the problem solving, the questions which come in your competitive examinations, right? So our main focus will be that. So I will just go through this initial theoretical formulas and part fast, right? Now cos 2a, what is cos 2a? Cos square a minus sin square a. Cos square a minus sin square a. 1 minus 2 sin square a, 2 cos square a minus 1, 1 minus tan square a upon 1 plus tan square a. So these are the formulas for cos 2a. Similarly, 1 plus cos 2a is 2 cos square a, and 1 minus cos 2a is 2 sin square a. These formulas are very useful, and you have to remember these. Now tan 2a is 2 tan a upon 1 minus tan square a. Similarly, you have formulas for 3a, sin 3a, cos 3a, and tan 3a. Sin 3a is like 3 sin a minus 4 sin cube a, and so on. Yeah, 3 sin a minus 4 sin cube a. Now next. Now comes these very important formulas which I would like to discuss with you, because most of the questions can be done directly. You can note these formulas, right? Now see the first formula. These formulas will help you to solve many problems very fast. Direct application of these formulas will help you out to solve many of the problems which come in competitive examinations. So here you just note these. First is see, if you have sin theta into sine of 60 minus theta multiplied by sine of 60 plus theta, this is equal to sine 3 theta by 4. And the proof is also very simple. We have just discussed this formula of sin a plus b multiplied by sin a minus b. This is what? If you see the last two factors on the left hand side, this will give you sine square 60 degrees minus sine square theta, right? And in the next step, the formula is proved. Sine square 60 is how much? What is sine 60? Root 3 by 2. So squaring it will give you 3 by 4. And if you take LCM here, what you will get? 3 minus 4 sine square theta by 4. And the moment this sine theta comes in, you get 3 sine theta minus 4 sine cube theta. 3 sine theta minus 4 sine cube theta, that is nothing but sine 3 theta. So the answer, it comes out, the formula becomes sine 3 theta by 4. Similarly, you have a formula for cos. Cos theta cos of 60 minus theta multiplied by cos of 60 plus theta is equal to cos 3 theta by 4. Second formula. And if you look at the third formula, the formula is slightly different. Tan theta, tan of 60 minus theta into tan of 60 plus theta is tan 3 theta. Now come to the fourth formula. See, the fourth and fifth formulas are again very important, which I would like to discuss first, so that while solving the questions we can apply them directly. Now see the fourth one. The formula is cos theta, cos 2 theta, cos 2 square theta. There is some misprint out there, right? And dot cos of 2 raised to power n minus 1 theta, right? You look here, cos theta, cos 2 theta, cos 2 square theta, cos 2n minus 1 theta. This is equal to sine of 2 raised to the power n theta upon 2 raised to power n sine theta. Here this L is not there. It should be 2 square theta and 3 some dots cos 2 raised to power n minus 1 theta is equal to sine of 2 raised to power n theta divided by 2 raised to power n sine theta. Now, how can you prove it? Can anyone tell me from left hand side how we can derive the right hand side? What you can do is you can multiply and divide by 2 sine theta to begin with, and then a chain will be formed and finally you will get the right hand side. Let us have a look. If I multiply by 2 sine theta and divide by 2 sine theta, right, then if you take this cos theta here, you will observe that it becomes sine 2 theta, right? So this is equal to 1 upon 2 sine theta, and this becomes sine 2 theta, right? Now once you get sine 2 theta, we take the next factor, cos 2 theta, right? Now what you have to do is you have to just multiply and divide by 2, so that we are able to apply the formula of 2 sin A cos A. You all know 2 sin A cos A is sin 2A, right? So this will become, it will continue to cos of 2 raised to power n minus 1 theta. Now if you multiply these, what will get? Sine of 2 square theta, sine of 2 square theta, and divided by 2 square sine theta. Now see the next factor. You see this cos 2 square theta. Now this will come cos of 2 square theta, right? Again we'll multiply and divide by 2. So what will happen if you write a 2 here and a 2 here? It becomes 1 by 2 cube sine theta, right? And this becomes sine of 2 cube theta. Now how many factors I have taken? 3. Till now I have taken 3 factors. And what I am getting? Sine 2 raised to power 3 theta. See, in fact the third factor will have 2 square. The power will not be 3 because in the first factor is cos theta. So what is happening? Finally, if you continue this process, the last one is the nth factor. So what you will get? 2n theta. Continuing like this, you will get 2n theta, and by that time 2 raised to power n will be the in the denominator. So 2 raised to power n sine theta. This sine theta will continue. So this is just a way to learn it, but most of the times if there is a MCQ question, you can apply this formula directly and solve the questions, right? Now you see the fifth formula as well. Fifth formula is sine alpha This is a series, summation of sines. Sin alpha plus beta plus sin alpha plus 2 beta, and it will continue, and the nth term is sine of what? Alpha plus n minus 1 beta. Right? This L is not there. This is the last term. You can put 3 dots here. And what is the summation? Sine of n beta by 2 divided by sine of beta by 2 and multiplied by what? Sine of, see how you can remember, you can take the first angle alpha plus the last alpha plus n minus 1 beta by 2. So what you do is, the best way to remember this is sine of, you take alpha plus alpha minus n minus 1 beta, the angle which is there in the last term, by 2, right? And then multiplied by sine n beta by 2 upon sine beta by 2. What is beta? Beta is the common difference. Alpha plus beta, alpha plus 2 beta, right? What is the difference between these two terms? Beta. So sine of beta by 2, half of common difference by 2, and in the numerator sine of n times beta by 2. Similarly, you have a formula for cos. You have a formula for cos. The only difference between these two formulas is that, see, in place of sine you will have cos. In place of sine you will have cos. You will take the first angle alpha, last nth term you add this. So alpha plus n minus 1 beta by 2, and this factors, they are of sine again. Don't write cos here. It is sine n beta by 2 divided by sine beta by 2. And these formulas can also be proved. Now the seventh formula. You know tan of a plus b is tan a plus tan b upon 1 minus tan a tan b. If you have tan of a plus b plus c, sum of 3 angles, right? Then the formula is sigma tan a. Sigma tan a means you will take summation of all 3 tans, tan a plus tan b plus tan c, right? Minus tan a tan b tan c, and divided by 1 minus what? What is this? Summation of 2 factors at a time. So basically when you write it in expanded form, this will be tan a tan b plus tan b tan c plus tan c tan a, right? And outside you have a minus sign. So this is clear to you? Now see this 8th point. You take any real number p, you add 1 by p to it. You take a real number, you add its reciprocal. What will be the answer? It will always be greater than equal to 2. You take any real value p, you add 1 by p to it, that will always be greater than equal to 2. And it will be equal to 2 only when p is equal to 1. If you take the value of p as 1, you will get the value 2, equal to 2. Equality will hold when x is or p is 1. Otherwise, the value will always be greater than 2. Like suppose you take 3. What is 3 plus 1 by 3? Obviously, it is greater than 2. Similarly, p plus 1 by p will be less than or equal to minus 2 if p is negative. See, there is a condition here. The first formula is applicable when p is positive. And when p is negative, if p is negative, then p plus 1 by p will be less than or equal to minus 2. Here also the equality will hold only when p is minus 1. When p is minus 1. And in the first one, the equality will hold when p is equal to 1. But for this positive and negative, you have these 2 different formulas. Now, finally, what are conditional identities? Conditional identities are the identities which work under a condition. What condition? There can be any condition given, but usually in your exams, the main condition which is used is we take a triangle. So what is the sum of the 3 angles of a triangle? A plus b plus c equal to pi. So if we are proving an identity, right, in which we consider a plus b plus c is equal to pi radians, and then we prove an identity, we can always use a plus b plus c equal to pi. Then it is a conditional identity, right? And in a triangle, see, if you take a plus b plus c is pi, you can easily prove this. You can prove this result also. So there are a set of what you call these conditional identities which are true for a triangle, and I have written some of them. Next, Now, before starting with the questions, I would like to discuss the last topic here, which is general solution of trigonometric equation. What's the meaning of general solution of trigonometric equations? What is the difference between principal solution and general solution? Now, let us say suppose we want to solve sin theta equal to half. How many solutions sin theta equal to half has? These are multi-valued functions. All of you know trigonometric functions are multi-valued. You will have infinite solutions. Sin theta will not be half at just one x. Sin theta, if you take theta is equal to, let us say, 30 degrees, you know sin 30 degrees half. But when you draw the curve, you will observe that sin theta is half at infinite values of theta. That is the general solution. General solution means you have to take all possible solutions. Now let us just see how this happens. This is x-axis. This is y-axis. Right? You know the sine curve? This is a sine curve. It will continue like this. What is the period of a sine curve? 2 pi radians, right? Let us say this is 0, this is pi, this is 2 pi. Period of sine curve is 2 pi radians, cos curve is also 2 pi radians, and tan curve is pi radians. Yeah, we are measuring the angles in radians now. So see, why 2 pi radians? Because in this 2 pi radians, the sine curves completes its complete revolution, and one crest and one trough is formed. All possible values of sine is taken, and it is the smallest angle in which this happens. And what is the amplitude? 1. The maximum value of sine curve is 1, sine theta is 1, and the minimum value of sine theta is -1. So the sine curve will continue to oscillate between -1 and 1. So these curves should be clear to you, right? And you have to be careful that it has to be symmetrical, and the period and the amplitude will be same. If this is the pi and the next pi will be this, and it will be exactly of the same. You're getting my point? If this is 2 pi, I'll just we have to be slightly careful while drawing these curves. So this is pi, 2 pi, 3 pi, 4 pi, right? Yeah, and here also it will continue on the, yeah, this is minus pi, then minus 2 pi. Now if we want to see, solve this equation sin theta equal to half. Half is somewhere here. So you know sin theta is half when theta is equal to how much? 30 degrees. That is how many radians? Pi by 6 radians. Sin theta is half when theta is pi by 6. Which other quadrant sin theta is positive? Which other quadrant?
First and second.
Second. So sin theta will be half again in the second quadrant. Sin of pi minus theta, all of you know, is sin theta. Sin of pi minus theta is sin theta. So the other angle will be pi minus pi by 6, which is how much? 5 pi by 6. Now, if you draw a straight line from this point, right, you will observe that sin theta takes the value half, not just at pi by 6 and 5 pi by 6, not just at these 2 points, pi by 6 and 5 pi by 6, but it is again taking the value half at this point. You know what is this? 2 pi plus pi by 6. And this, what is this? X or theta? 2 pi plus 5 pi by 6. Right? Because of the periodicity, when you keep on adding 2 pi radians, the value of sine theta will remain the same. So this is what? What will be this? Pi by 6, 2 pi plus pi by 6, 4 pi plus pi by 6. Then 6 pi plus pi by 6. Then 8 pi plus pi by 6. And similarly, 5 pi by 6, it will also continue. 5 pi by 6, 2 pi plus 5 pi by 6. And this will be what? How much? 4 pi plus 5 pi by 6. So these are known as general solution. And we have a formula for all of these. What is the formula? We don't have to do it like this. The formula is, if sine theta is equal to sine alpha, you can note down sine theta is equal to sine alpha, theta is equal to n pi plus minus 1 raised to the power n alpha. This gives you the general solution. Sine. Similarly, suppose you want to solve for cos. Cos theta is cos alpha. Yeah, formula will be theta is equal to 2n pi plus minus alpha, where n belongs to z. Remember this. N in both these cases belongs to z. And if you have tan theta equal to tan alpha, then theta is tan theta is equal to tan alpha, then theta is equal to n pi plus alpha. Right? And in case principal solution will be the numerically smallest angle, right? Like pi by 6. Now if sine theta, there are three more formulas. Sine theta is 0, theta is equal to n pi. You can see at every integral multiple of pi, sine theta vanishes, because the curve is cutting the x-axis at all multiples of pi, 2 pi, 3 pi. Not only this, minus pi, minus 2 pi. So the formula is sine theta is 0, theta is n pi, n belongs to z. What about cos theta equal to 0? Cos theta is equal to 0. Theta is odd multiple of pi by 2. Cos theta is 0 when theta is equal to odd multiple of pi by 2. And what about tan? Tan theta is 0 again at n pi, because tan is what? Sine by cos. And tan theta will vanish when sine theta will become 0. So tan theta is 0 when theta is equal to n pi. And in case you have square of this, sine square theta is equal to sine square alpha, then the formula becomes n pi plus minus alpha. In case you have sine square theta equal to sine square alpha, theta is n pi plus minus alpha. And this formula is true for all t ratios. It is true for all. This is general solution. Suppose you want to find the formula for cos square theta equal to cos square alpha. While solving, finding out the general solution, you come with the case in which cos square theta is equal to cos square alpha. What formula you will apply? Theta is equal to n pi plus minus alpha. Theta is equal to n pi plus minus alpha, n belongs to z. Right? Now, and similarly for tan square also. Tan square theta equal to tan square alpha, theta is again n pi plus minus alpha. So for all t ratios, whether it is sine square equal to sine square alpha, cos square theta is cos square alpha, or it can be even cosec square theta equal to cosec square alpha, the formula will remain the same. Theta is equal to n pi plus minus alpha, and n belongs to z. Is that clear to you? Now, besides this, there are 2-3 more things, and then we'll switch to the questions. There are some formulas known as sum formulas. Abhi, the formulas which we have discussed here were which one? Addition formulas. Now comes sum formulas. Sum formulas are sin C plus sin D, sin C minus sin D, cos C plus cos D, and cos C minus cos D, right? So I'll just write one or two. The remaining you can write 2 sin C plus D by 2 cos C minus D by 2. See what some formulas do? They convert summation of T ratios into product. Transformation हो रहा है from sum to product. Sin C minus sin D is what? 2 cos C plus D by 2 sin C minus D by 2. And similarly cos C plus cos D, 2 cos C plus D by 2 multiplied by cos C minus D by 2. Right? And cos C minus cos D minus 2. See either, yeah, there are two ways, but you can remember it like this: minus 2 sin C plus D by 2 multiplied by sin C minus D by 2. Right? Now, finally, we have some formulas which are known as product formulas. Right? Product formulas you know, and that those formulas you can derive just by adding the addition formulas. Right? Product formulas. Two sin A cos B. What is 2 sin A cos B? Sin A plus B plus sin A minus B. And you can just see their addition formulas. Sin A plus B, sin A minus B, you add, you will get this. And now, what is 2 cos A sin B? It is the difference of these. This minus this. And 2 more to go. 2 cos A cos B. What is 2 cos A cos B? Cos A plus B plus cos A minus B. And 2 sin A sin B. 2 sin A sin B is cos A minus B minus cos A plus B. So, you know, in cos A minus B minus cos A plus B. Now, you must remember these formulas, and with the help of these formulas and some of the questions, we'll try and solve and see how they will be applied. Now come to see the first question. These are MCQ questions, and most of them have a single option as the answer, but some of them might be having more than one. See the first one. Try it out. All of you see what can you find out what the answer will be. Sin 50, sin 10, sin 70. See, the first one is, if you look at the angles, you will find one of the angles, if you take as theta, the other two are 60 plus theta and 60 minus theta. But you have to observe it, right? Rather than just to solve the problem, you have to find out what is the trick which is involved so that you can get the answer fast. So if you take 10 degrees as theta, right? Sine of 10 degree, sine of 50 degrees, and sine of 70 degrees. Now, if this is theta, 10 degrees, this is what? 60 minus 10, 50 degrees. And the last one will be 60 plus 10. So now you have that identity. You remember sine of theta, sine of 60 minus theta, and sine of 60 plus theta is equal to sine 3 theta by 4. Sine 3 theta by 4. Apply that, you will get the answer. Now tell me what is the answer. Sine of 3 theta by 4. Theta is how much? 10 degrees. So sine of 3 theta by 4 will give you sine of 30 degrees by 4, because theta is 10 degrees. And sine 30 is 1 by 2. So this becomes 1 by 8. So what's the right answer? C. Next, please. Now next you try. Second one I can give you a hint. It is similar to one which we have done. Similar formula you have to apply. You have to just look at the angles. Second, value of tan 20 degrees, tan 40, and tan 100. Now theta you take as 40 degrees now. Let this be theta. Now what is 60 plus 40? 100 degrees. 60 plus 40 is 100. So if this is theta, this is 60 plus theta. This is 60 minus 40 is 20. So this is 60 minus theta. And you know the formula for this is tan 3 theta. You don't have to divide by 4, just tan 3 theta. So what is tan 3 theta? So this will be equal to tan of 3 theta, which is equal to tan of theta is 40 degrees. So 40 into 3 is 120. And you can solve this by writing 90 plus 30. And tan of 90 minus 90 plus 30 is minus cot 30 degrees. Because which quadrant it will lie? Second quadrant. And you are splitting by 90 degrees. Right? So when you split by 90 degree, T ratio will change. Always remember, when you split an angle by 90 degree or 270 degrees, that means when you are splitting an angle by pi by 2 or 3 pi by 2, the T ratio will always change. Sine will change into cos, and cos will change into sine. Tan will change into cot, and cot will change into tan. Secant will change into cosecant, and cosecant will change into secant. So that is the reason. And finally, this is 1 minus 1 by tan 30 degrees, and tan 30 is 1 by root 3. So this becomes minus root 3. So what's the answer? Minus root 3a. Now let us see the third question. Now how will proceed with this question? You have the difference of cot and tan. Try and exploit that difference of cot and tan. Cot of 10 degrees minus tan of 10 degrees. See what it gives you and whether you can generalize it or not. Third, or just for that matter, you can take cot theta minus tan theta. Let us see what cot theta minus tan theta will give you. This will help us to solve this problem. See the first two terms here are cot 10 minus tan 10. Let 10 degrees be theta. So cot theta minus tan theta. See, if I write it as cos by sine, cot is cos by sine minus sine by, right? Cot is cos by sine minus sine by cos. Simplify this. This gives you, if I write sine theta cos theta as our LCM, you will have cos square theta minus sine square theta. Now if I multiply and divide by 2, so that we have sine 2 theta in the denominator, what we'll get? Twice of cos 2 theta upon sine 2 theta. You know, 2 sine theta cos theta is sine 2 theta, and cos square theta minus sine square theta is cos 2 theta. So we get, finally what we get? Twice of cot 2 theta. So this identity we will use. Cot theta minus tan theta is equal to twice of cot theta. Cot theta minus tan theta is equal to twice of cot 2 theta. The angle is doubling. See what is happening. Here we have theta, on the right hand side we have 2 theta, and this 2 factor also comes in. So cot theta minus tan theta is twice of cot 2 theta. And if you already know this, you can do it very fast. Even this time you can say. Basically, right now I am explaining you how to go about it. But these things you have to know beforehand. See now. If you look at the problem, cot 10 minus tan 10 will be twice of cot 20 degrees. If you look at the first two terms, just look at the first two terms. See, question number 3rd. Cot 10 minus tan 10 minus twice of tan 20 minus 4 times tan 40 degrees minus 8 times cot of 80 degree. Right? Now this will give me twice of cot 20 degrees. The first two. Now if I take the next term minus 2 tan 20, right? You can take 2 common from here. Again you apply the same formula. You get twice of cot 40 degrees. So outside you have 2, and then you get twice of cot 40. So what you end up with? 4 cot 40. And then next this term will come in, which is minus 4 tan 40. You take 4 common. You get what? Cot 40 minus tan 40. Now again this will become twice of cot 80. So 4 multiplied by twice of cot 80 gives you 8 cot 80, right? 8 cot 80 degrees. And finally when you take this last term, which is minus 8 cot 80, the net value will be 0. Is that clear? So value of this expression will come out to be 0, and this is how you have to go about it. Now you try 4th. The faster you do, the better it is, because we'll be able to take up more questions. Now sec theta minus tan theta is 3. Question number 4. Sec theta minus tan theta equal to, you have to find value of cos theta. You know, if sec theta minus tan theta is given to you, what will be sec theta plus tan theta? It will be reciprocal of the number. If sec theta minus tan theta is 3, you can easily show that sec theta plus tan theta will be equal to 1 by 3, right? These identities hold. Whatever is the value of sec theta, what is sec theta minus tan theta into sec theta plus tan theta? Product of these two. Sec square theta minus tan square theta. What is sec square theta minus tan square theta? 1. So once you know the value of sec theta plus tan theta, you can find the value of sec theta minus tan theta just by reciprocating, and the other way around. So if we are given the value of sec theta minus tan theta is equal to 3, then value of sec theta plus tan theta will be equal to 1 by 3. Now just we want sec theta, add the two. Now adding 1 and 2, what you will get? This will cancel out. 2 sec theta is equal to 10 by 3. Now sec theta is equal to 5 by 3. What is cos theta? 3 by 5. So what's our answer? B. Let's see who can solve this. Fifth one. Fifth question is Fn theta, there's a suffix there n, Fn theta is equal to tan theta by 2 1 plus sec theta into 1 plus sec 2 theta, and further we multiply it till 1 plus sec 2 raised to power n theta. So here in place of L there is a misprint out there, you put 3, yeah, this is the last term, you put some dots here. So fifth question is see the fifth one. Fn theta is tan theta by 2 multiplied by 1 plus sec theta, 1 plus sec 2 theta, 1 plus sec 4 theta, and like this it is up to 1 plus sec 2 raised to power n theta. See, here you have to make a generalization. See, these questions, if you don't follow the proper method, becomes very difficult. And if you can somehow crack them, if you can understand what the concept behind these are, then they become very easy. Now you see, if I take the first factors here, I would like to simplify just these two, right? See, tan theta by 2, let me simplify the first two factors. Sec is 1 plus 1 by cos, right? So this will be sin theta by 2 upon cos theta by 2. And what about this? This will be 1 plus cos theta by cos theta. What is 1 plus cos theta? One plus cos theta is 2 cos square theta by 2. 2 cos square theta by 2. And this is cos theta. Now this cos theta cancels out. What is 2 sin A cos A? Sin 2A. So this is sin theta by cos theta, which gives you tan theta. So solving the first two factors gives me tan theta. So this whole thing reduces to tan theta. So what you observe, tan theta by 2 multiplied by 1 plus sec theta gives tan theta. So what is happening? If you take these two factors, then the power of tan is doubled. Sorry, not the power, the angle of tan is doubled. Initially it was theta by 2. On multiplying with 1 plus sec theta, it becomes tan theta. Now the similar situation we are facing again. If you look at the next two factors here, we have tan theta multiplied by 1 plus sec 2 theta. tan theta multiplied by 1 plus sec 2 theta. So as tan theta by 2 multiplied by 1 plus sec theta became what? Tan theta. Multiplying this will give me tan 2 theta. These two. Right? And then this tan 2 theta, multiplied by this 1 plus sec 4 theta. 4 theta you can even write as 2 square theta, so that it is easier to generalize. This 4 you can write as 2 square. So what will happen now? If you multiply these two, tan 2 square theta. So see, there is a pattern which is formed here. When I multiply tan 2 theta with 1 plus x square 2 theta, I get tan square tan of 2 square theta. It is not tan square, it is tan of 2 square theta. It is a linear function of tan. Now if you like multiply, continue like this, finally you have this factor. See, when the final factor was 2 square theta, we got tan 2 square theta. So this is the angle in the last factor it becomes the angle of tan. So finally when you will multiply this, yeah, what you will get? Tan of, very good. This is what you will get. This is what Fn is. Fn theta is. Now this whole expression we have reduced to, on multiplying this we have shown it will get reduced to tan of 2 raised to power n theta. Now which one of the options is correct? See the first one. F of 2 pi by 16, right? So this will be tan of 2 square pi by 16, which is what? Tan of pi by 4. And what is this? Tan pi by 4 is 1. So what do you think is the correct right option? 1. But you should verify the other options as well. This is a question in which all the options are correct. If you look at, let us say, C part, f of what is, or you take the third one, B part, f3 pi by 32, right? So this will be equal to tan of 2 cube into pi by 32. So 2 cube is 8. Again you will get pi by 4. So this will also be 1. And if you take the last one, that is f5, pi by 128, right? f5 is what? Tan of 2 raised to the power 5 into pi by 128. What is 2 raised to power 5? 32. So again you will get 32 will get pi by 4. So this is also 1. So you should be careful in examining all the options and then answering. Next. You now see the sixth question and try to solve it. I'll give you a minute for this. Theta is equal to pi upon 2n plus 1. You have to find the value of cos theta, cos 2 theta, and this is continued till cos of 2n minus 1 theta. And there was a formula which I mentioned and I told you have to apply these formulas. Cos theta, cos 2 theta, cos 2 square theta, and till cos 2 raised to power n minus 1 theta. Again, in place of this L, there is a misprint. You put 3 dots. And tell me what the answer will be. So this is a direct application. In question 6, they have asked us to find value of cos theta, cos 2 theta, cos, next will be 2 square theta, 2 cube theta, and so on till cos of 2 raised to power n minus 1 theta. You remember what is this equal to? Very good. Sine of, this is equal to sine of 2 raised to the power n theta upon 2 raised to power n sine theta. This formula we have to apply. Now what besides this is given to us? Theta is equal to pi upon 2n plus 1. So now if you cross multiply, you will get 2 raised to power n theta plus theta is equal to pi. Now what is 2 raised to power n theta from here? 2 raised to power n theta is equal to pi minus theta. Now this 2 raised to power n, value of 2 raised to power n, I'll substitute here in this so that it gets simplified. Sine of 2 raised to power n theta is pi minus theta, right? And sine of pi minus theta upon 2 raised to power n sine theta. What is sine of pi minus theta? It is sine theta, second quadrant. You are splitting by pi. So this will cancel with this. So what will be your answer? 1 upon 2 raised to power n. So the right option is A. See, directly you can apply this formula, and then from this you have to find value of 2n theta, which you can substitute here to simplify this. Now next 7th, I expect that you can do it. Again the same formula. You have cos theta, theta is pi by 7. Next factor is cos of 2 theta, and third factor is cos of 2 square theta. So cos theta, cos 2 theta, and cos of 2 square theta. And what this will be equal to? There are 3 terms. When there are n terms, you have sine 2 raised to power n. When you have n terms, you have sine 2 raised to power n. Now if pi by 7 you write as theta, you will observe that this whole becomes sine of, there are 3 terms. So 2 raised to power 3 theta. And what is theta here? Pi by 7. Divided by what? 2 cube sine pi by 7. Very good. See, now you are able to understand how these questions are done. Now we can simplify this. This gives us sine of 8 pi by 7 divided by 8 sine pi by 7. And this is nothing but pi plus pi by 7. 8 pi by 7 you can split like this. 8 sine pi by 7. Now what is sine of pi plus theta? Isn't it minus sine theta? Right? So this will be minus sine pi by 7. And in the denominator you have 8 sine pi by 7. Sine pi by 7 will cancel out. So what will be left? Minus 1 by 8. So what is the right option? B. B. Good. Now look at this 8th one. It is based on the same formula, same concept, but slightly different. Because here, if you take x by 2 as theta, then the next is not twice of x by 2. In the next factor, the angle is not being doubled. So now how to manage this? Huh, what? Reverse, very good. Reversing it will help us. Reversing it will make it in that proper form. Please ask your question. So we can take up later. So now see this question 8. You have cos x by 2. cos x by 4, cos x by 8, and finally you have cos x by 2 raised to power n. So what we can do is writing, if you take it in the reverse manner and you take this as theta, let theta is equal to x upon 2 raised to power n. Now this whole expression will become what? If this is cos theta, the next one will be what? The one which is prior to this second last term. That will become 2 theta. See, when you multiply x by 8 by 2, you get x by 4. When you multiply x by 4 by 2, you get x by 2. So in the reverse direction, it is being multiplied. So finally, the same thing you will get cos of 2 raised to power n minus 1 theta, and the value of this you know is sine of 2 raised to the power n theta upon 2 raised to power n sine theta. Now, if theta is equal to x raised to power 2n, 2 raised to power n theta is equal to x. So this is equal to sine of, what is the option? Sine x, right? 2 raised to power n sine theta. What is value of theta? X upon 2 raised to power n. Which option is this? C. Now ninth, you know how to find range of a function of the form a cos x plus b sin x, or a cos x minus b sin x. It is very simple. The value of this expression, you can write, this is a classical treatment. What we do is, look at this expression, a cos x plus b sin x lies between minus of a square minus b square and a square plus b square root. Right? Whether you have plus sign in between, you have minus sign in between, this will hold. So ninth question, what will be this? What is a given to us? 3. And what is b? What is b? Minus 4. Right? So 3 cos x minus 4 sin x. So this lies between what? 3 square plus 4 square square root and minus of same 3 square plus 4 square. Right? So this range of this expression is what? The value of this will lie between minus 5 and plus 5. And closed interval. Minus 5 and plus 5. So which answer is correct in this case? Question 9th? C is correct option. Now similarly, you tell me fast. In 10th also, the same approach you will use. What about this question? 10th. The range of 3 sin x minus 4 cos x plus 10 is what? See, if you look at 3 sin x minus 4 cos x, 3 sin x minus 4 cos x, this expression will lie between, again, minus 5 and 5. Right? This is what we have learned, 3 square plus 4 square square root minus and plus. But here we have 10 also. If you add 10 to it, you have to add 10 on all sides of the inequality. So finally, this expression will lie between how much? 5 and 15. 5 and 15. So what is the right option for 10th? B. What about 11th? Can you make a effort to find out? 11th is also similar, but be careful, you have a modulus sign there. In the previous two questions, the modulus was not there. Here you have a modulus sign. Now, because of the moduli, you will note that the value can never be negative. The minimum value of mod function is always 0. So this expression, which is inside the modulus, will lie between 0 and 5. The maximum value will remain 5. So when this expression remains between 0 and 5, on adding 10, what will happen? Yeah, if it lies between, the mod expression lies between 0 and 5, you add 10. 10 to this plus and 10 to this. So the final answer here will be 10 and 15. So what is the option? This is which one? 11th? A. Now try the 12th one. 12th question, you have to find the value of this expression 1 minus sine 2x inside the square root sign. What will be this equal to? Find the value of 1 minus sine 2x inside the square root. See, you know this, that generally while writing square root of x square, students have tendency to write x, right? What is wrong with this? There is some error in this. Plus minus. Why plus minus? Square root of a number is always positive. When you are writing plus minus, so you are inviting trouble. You are saying sometimes it may be, see, out of, if you write both plus minus, one of them will be negative. And how can the square root of a number be negative? So what you do is, we write mod of x. We don't want minus, and we don't know what x is. X can be negative also, where it's written that x is positive. Let us say x is minus 3. X is minus 3. Then this will be 3. Yeah, mod लिखना important है. अभी इधर देखो, in this question number 12th, we have to find value of this expression 1 minus sine 2x, and it is inside the square root. Right? Now, what is 1? Cos square x or sine square x plus cos square x, and sine 2x is 2 sine x cos x. Now, if you write it as a whole square format, sine x minus cos x whole square root. Now, as I have just told you, you have to write mod. So what will be this expression equal to? Sine x minus cos x mod. And you know, mod will make sure that the answer is positive. Now, out of these options, if you look, which is the correct option? Now, if you write, you see the sine curve. Sine curve is like this, right? In 0 to pi radians, this is the sine curve. Sine x. Now, cos x. If I draw the cos curve also on the same axis as sine, cos 0 is 1. It will start from here, right? And cos of 90 is 0. Then it will further go down and like this. Now, the point where the two curves will intersect is pi by 4. This is pi by 4. Now, if you look at the domain between 0 and pi by 4, cos curve is greater than sine curve. This is the cos curve. So if in 0 and pi by 4, the value of this expression you can write as cos x minus sine x. If you want to get rid of this modulus sign, between 0 and pi by 4, you can write cos x minus sine x. And where is cos x minus sine x? Yeah, it should be. Yeah, there is some error in the this options. The right answer here is between 0 and pi by 4. Between 0 and pi by 4, the answer will be cos x minus sine x. You just write it down. The right option will be, wherever the question comes, you will write cos x minus sine x when x lies between 0 and pi by 4. And when it is between pi by 4 and pi by 2, what will be the correct option? When it is between pi by 4 and pi by 2, what will be the correct option? What is coming first? Sine curve is coming first. See, sine curve takes a lead, right? See here, sine curve is coming first and the cos curves go down. Sine curve is in the upper curve is sine curve and the curve which is below is cos curve. So sin x minus cos x. So the right option is sin x minus cos x in pi by 4 to pi by 2 and cos x minus sin x between 0 and pi by 4. Maybe these options are not correct. One of the options is correct here. Yeah, B is correct. Sin x minus cos x between pi by 4 to pi by 2. You can have multiple answers also. Both of them can be there. Please, next. Yeah, tell me this 13th. The general solution of this. And be careful while solving too. Don't jump to the answer. Just verify it also. You know, when the equations you are solving and you get an answer, it is always, it makes sense to see whether the equation is satisfied or not. Now, if you look at this 13th question, what is tan A minus tan B upon 1 plus tan A tan B? Tan of A minus B. Tan A minus B is tan A minus tan B upon 1 plus tan A tan B. This is equal to 1. And what is 1 equal to? Tan of pi by 4. So tan of x is equal to tan of pi by 4. Right? Now, if you apply the general solution formula of tan, what is tan theta equal to tan alpha? Theta is equal to n pi plus alpha. And where n belongs to z. Now you tell me which is the right option. If I put n is 0, if I put n equal to 0, I'll get pi by 4. If I put 1, I'll get pi plus pi by 4. And what is pi plus pi by 4? 5 pi by 4. And if I put n equal to 2, what I'll get? 8 pi by 4? 9 pi by 4. Similarly, if I put, let us say, 3, 13 pi by 4. 13 to nahi hai because maybe they have some specific, the interval should have been there between 0 and, let us say the interval is between 0 and 2 pi. 0 and 2 pi. So what is the right answer? According to you? Pi by 4, 5 pi by 4, 9 pi by 4. All of these. All of these is not there. No, that is none of these. So if it is a multiple, see more than one option. Listen, if more than one option is correct, then also you will not mark A, B, C, because the actual answer is none of these. It is a very deceptive question, and that is the reason I was telling you, you should substitute and check. Now the problem in this is, let us say we want to see what happens at pi by 4, right? Now if you put pi by 4, x is pi by 4, what is 2x? Pi by 2. 2x is pi by 2. See the second term of the numerator, tan 3x minus tan 2x, and the last factor tan 2x. See, tan 2x is not defined. Tan theta is not defined at pi by 2. At odd multiples of pi by 2, tan theta is infinite. It is not defined. So how come the value will be 1? Indeterminate form. You're getting my point. See, 5 pi by 4 is also coming, but when you take 2x, this is x, it becomes 10 pi by 4, which is what? 5 pi by 2. And if you double this, you get 9 pi by 2. So at all these are odd multiples of pi by 2. So the actual answer is none of these, because the value is not defined, right? Now come to the 14th. If sin alpha 1 cos 2 alpha are in GP, geometric progression, then value of alpha is what? You have to again find the general solution. In this question, previous question, that interval should have been given. Now if sin alpha 1 cos 2 alpha are in geometric progression, what will be the value of alpha? Now, if they are GP, the product of the extremes is equal to the square of the middle. You know what is GP? A, B, C are in GP. If their common ratio is same, you are multiplying by the same constant, non-zero constant, obviously. So here what will happen if these are in GP? Sine of alpha multiplied by cos of 2 alpha is equal to 1 square. A, B, C are in GP. You know, A, B, C are in GP. If B by A is equal to C by B, C by B, the common ratio is same. So B square is equal to AC. So applying this formula of 3 numbers in GP, we get this. Now we have to somehow find out the value of alpha. So this is sine alpha. Cos 2 alpha is what? 1 minus 2 sine square alpha. This is equal to 1. Now if you simplify this, you get sine alpha minus 2 sine cube alpha is equal to 1, or minus 1 equal to 0. Let us substitute sine alpha is equal to x. I am substituting sine alpha equal to x. And this becomes 2x cube minus x plus 1 equal to 0. Can you tell me a root of this? X equal to minus 1 or 1 you can verify. X equal to minus 1 seems to be a root, because if I substitute x equal to minus 1, this becomes minus 2 and this becomes 1 and this is 1. So if you can verify by factor theorem. Factor theorem you can substitute minus 1 and see this whole expression is becoming 0. Right? So x minus 1 is one of the factors. And if you divide this expression, listen, if you divide this expression by x plus 1, whatever quadratic you will get will give you, simplifying this equal to 0, will give you the other roots. This is what you have learned earlier. When you have to find the roots, you get one root by the factor theorem. The other root, you divide the main expression with that factor, right? This will give you, and when you will find this expression, you will find its discriminant is coming out to be negative. So yeah, this discriminant is coming out to be negative. It gives you imaginary values. So the only solution is x equal to minus 1. So which is sine alpha is equal to what? Minus 1. And what is minus 1? Sine of minus pi by 2. So applying the general solution, sine theta is sine alpha, theta is equal to n pi plus minus 1 raised to the power n into pi by 2, minus pi by 2. So this one can you can write here. So what is the right option? Is this option there? Maybe there is some error in the sense the same option has been repeated. So this is the right answer. In fact, in the first case, this should have been pi by 2. So this is pi by 6, this is pi by 4. So make pi by 2 here. In the first option, you write pi by 2. And that is the right option. Now come to the next question, 15th. 15th, I think you can try. See, there are many problems. I would like to do the important ones because of the scarcity of time. So let us skip this. I can give you a hint. Tan theta plus tan 2 theta plus tan theta tan 2 theta is 1. So if you take this tan theta tan 2 theta to the right hand side, you will get 1 minus tan theta tan 2 theta. Then you divide. So tan A plus tan B upon 1 minus tan A tan B is tan A plus B. So finally this will take the shape tan 3 theta. You're getting my point? Tan A plus tan B, take this shift to the right hand side, 1 minus tan theta tan 2 theta, and when you will divide, you will get tan 3 theta. Tan 3 theta is 1, you have to solve. Tan 3 theta is 1 will give you tan 3 theta is equal to tan pi by 4. And 3 theta is equal to n pi plus pi by 4. Theta you get by dividing, right? One of the options I hope will be correct. Next. B is correct. Now see this question, 16th. 16th question. Is important. You can see the font size is, I'll just tell you the 16th question. The most general solution of 2 raised to the power you can write down 1 plus mod cos x mod of cos x square plus mod of cos x cube up to infinity. This is equal to 4. The value of this expression is 4. Find the value of x. General solution of this. Obviously, we have to find x. This is the problem. 1 plus mod cos x plus mod cos x square plus mod cos x cube and so on to infinity. Now, if you simplify this expression, right, this is infinite geometric progression. This is infinite geometric progression. And if you have an infinite geometric progression of this type, let us generalize it ar square, ar cube up to infinity. Yeah, then the formula is a upon 1 minus r. Sum of infinite terms of a GP is this. And you have to ensure that here the common ratio has to be less than 1. Then only it will converge. The common ratio cannot be greater than 1 in case of infinite GP. And you know mod of cos x obviously will be less than 1. And if you apply this formula, what you will get? 1 upon 1 minus r. R is the number by which we are multiplying. Mod cos x. Again, you are multiplying by mod cos x. So this. So this is equal to 4 is 2 square. It is equal to 4. It is equal to 2 square. Now, when these two are equal, these two will be equal only when their powers will be equal because the bases are same. The base in both the case are 2. So this will imply 1 upon 1 minus. This is equal to 2. Now, if you cross multiply, what you will get? 1 is equal to 2 minus 2 mod cos x. So this will be twice of mod cos x is equal to 1. So what is mod cos x? Half. Is it correct? 1 upon r, 2 minus 2 mod cos x. 2 mod cos x is 1 half. Now, see, whenever the modulus is there, you can square both sides. Why you can square both sides? You don't carry the risk of getting some extra roots because of the moduli. Because moduli will ensure plus minus is there. So if you square this, this is half square. Half is what? Cos of what angle you will take so that it becomes half? Cos of what angle is half? Pi by 3. Cos pi by 3 is half. So I can write like this. Now cos square x is equal to, you remember this formula I have told you, cos square theta is cos square alpha. What is the formula? Theta is equal to n pi plus minus alpha. So x is equal to n pi, right? N pi plus minus n pi plus minus pi by 3. So A is the first one is the right answer. N pi plus minus pi by 3, n belongs to z. What is the right option? A. Now we can skip through some questions which are of similar type and come to some different sort of questions. You can just move to around 24th or something. 24th. Let us do this 27th first. I'll just pick up questions at random, the important ones, and we'll discuss. 26 you can do. First we do 26, then 27, then 28 in this order, and then 29th. And if we have some more time, then we can take up few more. See the minimum value of 27 tan square theta plus 3 cot square theta. See, this question can be easily done if you know that arithmetic mean is always greater than or equal to geometric mean. And this you can easily prove also. See, let us take this 27th question, 26th first. You just apply if you can apply arithmetic mean, you know what is arithmetic mean of two numbers a and b? A plus b by 2. And what is geometric mean of two numbers a and b? Square root of a and b. And arithmetic mean is always greater than equal to geometric mean. So if one of the, you take a as 27 tan square theta, one number you take as 27 tan square theta, and the other number b you take as 3 cot square theta, and apply this result. A plus b by 2 is greater than or equal to root ab, and see, you will get the answer. Try it out. Uh, 26. Since arithmetic mean is greater than equal to geometric mean, right? A plus b by 2. Yes. Now substitute the values in this. A I am taking as 27 tan square theta. And b I am taking as 3 cot square theta. And the product will be 81 tan square theta cot square theta square root, right? And now you get the answer straight away. So this is nothing but, this will cancel out tan square cot square theta. What is square root of 81? 9. So 27 tan square theta plus 3 cot square theta is greater than equal to what? 18. This 2 will come on this side. So what is the minimum value of this expression? Minimum value is 18. So we have the right option. The right option is B. Now let us try 27th. See, some of the concepts here are based on determinants also, but I'll tell you what to do. How to, you know how to solve a determinant? See, there's a technique to solve a determinant, and then we can find the value of this expression will lie between what are the possible range. So what we do is, if you just see this question 27th, 1 sine theta 1 minus sine theta 1 sine theta minus 1 minus sine theta 1, then you have to find where the value of this delta will lie. So what we do is, see, there are certain tricks to solve this, but right now this is first column, this is second column, this is third column. If I apply this, column 1 becomes column 1 plus column 3, this becomes 2, this is 0, this is 0. You have sine theta 1 minus sine theta 1 sine theta 1, right? If you simplify this, you get twice of 1 plus sine square theta. So let us, for the time being, if I give you value of delta, later on when you will do this, you will know how to expand the determinant. I'm not going into the details of that. Suppose this is delta is given to you in place of determinant. Suppose this is given to you. Then what is the range of this expression delta? The highest value which this will take is sine theta. Highest value is 1. So the highest value of delta will be 4, because if this takes the value 1, this will be 4. And the lowest value will be when sine theta takes the value 0, because it is square. The minimum value will be 0, not minus 1, because you are squaring it. So when you write 0 in place of sine square theta, the minimum value is 2. So 2 and 4 is the option. A is the right option. Now 28th. I've already given you a hint that whenever you have sec theta minus tan theta, the value of sec theta plus tan theta will be reciprocal. So we'll use that concept. We'll use that concept to see 28th. tan theta is given to us. What is tan theta? A minus 1 upon 4a. Sec theta minus tan theta is equal to what? We have to find sec theta minus tan theta, right? Let us say sec theta minus tan theta is equal to x, or lambda you can take. Sec theta minus tan theta we assume is equal to lambda. Now, what is sec theta plus tan theta?
So 1 by lambda.
Very good. Now, 1 minus 2. What 1 minus 2 will give us? This will, the sign will get changed. This will cancel out. This is minus 2 tan theta is equal to lambda minus 1 by lambda. Now, tan theta I know. Tan theta ka value is given to us. So, what I'll do is, tan theta I'll first find. I'll change the sign 1 by lambda minus lambda and divide by 2. Or I can keep 2 on that side only, right? 2 will,
Tan theta.
yeah, 2 tan theta. Now, what is value of 2 tan theta? Tan theta substitute in this, a minus 1 by a minus 1 by 4a. What is tan theta? Yeah. Now, if you take this 2 inside, what you will get? 2a minus 1 by 2a is equal to 1 by lambda minus lambda. So now can you find out what will be value of sec theta minus tan theta? Because sec theta minus tan theta is lambda. Sec theta minus tan theta is lambda only. We have assumed lambda. So what possible values lambda can take? Lambda can take either the value minus 2a, or lambda can take the value 1 upon 2a. So what are the possible values of lambda? Possible values of lambda are minus 2a or 1 by 2a. If you substitute, you will find out. If you put minus 2a here, it becomes plus 2a, and if you put 1 by 2a, you get the other. Right? Now let us, we have some time. See this 29th question. Question 29th is, sec square theta is equal to 4xy upon x plus y whole square, where x and y are real numbers, is true if and only if. When this expression is true, this is what we have to find out. When sec square theta can be equal to this expression where x and y are some real numbers. Now, see, you know this identity x plus y whole square minus x minus y whole square is how much? 4xy. All of you know this algebraic identity. Now, x plus y whole square minus 4xy, if I take this to the other side and this to the right hand side, will be equal to x minus y whole square. See how these questions are done. Now, x minus y whole square is what? It is always positive or equal to 0. Square quantity will be greater than or equal to 0, and it will be equal to 0 when x is equal to y. Identity will hold only when x is equal to y. Now, this means x plus y whole square is greater than or equal to 4xy. When this expression is greater than or equal to 0, that means this expression is also greater than or equal to 0. So x plus y whole square is greater than or equal to 4xy. You agree to this? Now, x plus y whole square is greater than 4xy. So if you look at this expression, x plus y square is greater, that means the denominator is greater. The denominator is greater than the numerator. And when the denominator is greater than the numerator, then the value of the expression will be less than equal to 1. The value of the expression is less than equal to 1 because the denominator is greater. Now, what about sec theta? What is the range of sec theta? Sec theta is always greater than equal to 1. You know, cos curve, cos theta lies between -1 and 1. And sec theta is always, when you reciprocate a number which is less than or equal to 1, its reciprocal will always be greater than equal to 1. So sec square theta, on the other hand, is always greater than equal to 1. If this is the cos curve which I have drawn, sec curve will be like this. This is the sec curve. Its minimum value is 1 or -1, and then it tapers. You have asymptotes here also, asymptotic. These lines are known as asymptotes. So it will continue like that. So sec square theta, the minimum value will be 1 because it is square. Sec square theta, the minimum value is 1. So when this will hold, one expression is greater than equal to 1. It is equal to some other expression which is always less than equal to 1. So this will hold when only when these two are both equal to 1. So this will hold only when these two are equal to 1 because iska minimum value is 1 and here the maximum value is 1. So it will only hold when they are equal to 1. And when this expression will be equal to 1, who will tell me when this expression will be equal to 1? When x and y are equal. See, when x and y are equal, these two will become same. So this will be equal to 1 when x is equal to y. And obviously x should be non-zero. X should be non-zero because if x is 0, then it will become indeterminate. If you put x equal to 0, then the problem will crop up. Then the value will be 0. It will not be 1. It will not become indeterminate because in the denominator you will have y square. But if x is equal to 0, the value will become 0. But sec theta can never take the value 0. So the right option is x is equal to y and x is not equal to 0. So the right option is B. Now we can take up one more question. 19th, 19th, if you can. Nineteenth is based on log, so I want to just quickly see. Find the general solution of cos x raised to the power sin square x minus 3 sin x plus 2 is equal to 1. Find the general solution of this. Minus 3 sin x. Yeah, now this, if you convert it into log form, will be what? Log of 1 to the base cos x equal to sin square x minus 3 sin x plus 2. Now all of you know log 1 is 0. So this expression is 0. Solve this. If you put sin x is equal to y, you solve this y square minus 3y plus 2 is equal to 0. Just solve this, what you will get? You will get some values of y.
So 1 and 2. Y equal to 1 and 2.
Y is equal to 1 and 2. 1 and minus 2 or 1 and 2?
1 and 2.
हाँ?
So positive.
ठीक है, दोनों पॉजिटिव हैं,
So
राइट?
the second one.
Yeah. So what is y? Sin x. Sin x is 1 or sin x is 2. Sin x is 2 is not possible. So the general solution will be sin x is 1. What is sin x is 1? Sin x is equal to sin pi by 2. And sin x is equal to sin pi by 2, you know, is x equal to n pi plus minus 1 raised to power n pi by 2. So what is the right option?
B.
B. So B seems to be right. Is this clear to you?
Yes, sir.
So it involves log. You must know that exponential form of log as well as the logarithmic form. Here first we will convert it into, this is cos x raised to power, this is 1. You write it in this form, log of 1 to the base cos x is this. And base you must ensure is always a positive quantity not equal to 1, right? So those additional conditions should be fulfilled or they should be given. Now log 1 is 0, you solve this, you get two values of sine. Sine x is 1 or sine x is 2. Sine x can never be equal to 2. You know the maximum value is 1. So sine x is 1, you solve. Sine x is sine pi by 2. And you know sine theta is sine alpha, then theta is equal to n pi plus minus 1 raised to power n alpha. So there were many more questions, but maybe scarcity of time. We can take one. Thank you.